Bullshit, I can't hear you. Sound off like you got a pair.
Hey, Gumby. Hey, Chris, what's up, man? Happy Sunday, my fine gentleman.
Hello, IT. Have you tried turning it off and on again?
Actually, we had to do that quite a bit today because we were troubleshooting one of the ATVs while we were at the track. Chris, I got a funny story for you here. I'm going to start it though. I'm going to wait till the stream starts to tell you. Speaking of my beloved Marines, this is actually not about a Marine, but you're going to love it. It was a dirt track. Yeah, it was a motocross track. So there's one here. It's about an hour from my house, and we can go out there a couple times a month, 1 or 2 times a month, and they'll set aside a Sunday for us to go riding 4-wheelers. Typically, the track's restricted to dirt bikes, but the owner knows we're cool. He's an awesome dude. He set up a really killer track. The kids out there were just ripping it today, having a really good time. Nah, it's not so bad, man. It's pretty much all highway. There's a few small roads. This is a small motocross track. It's kind of tucked away in the woods, but we were out there all day. We got there at about, like, I don't know what time we got there. We got there early and we left late. It was a long day. Yeah, it's a nice way to go spend the day with my older son, but honestly, Honey Badger is getting old enough to start riding, so I may start him up soon. He's got to learn how to follow instructions, though. Kid's so hard-headed. It's almost time. All right, let's kick this off and light this candle. What's up, everybody? I hope y'all are having an absolutely amazing Sunday. So like I was just saying, I had a really good one today. We went out to a motocross track, took the quads out there, had a really good time. Can't say it wasn't all day if it wasn't all 24 hours. Oh, bite me, Gumby. So, yeah, it was pretty good, though. We got out there pretty early. We were riding today, and the kids were out there just ripping on it. Agent Zero actually ran out of gas in, I think, about 2 hours. So, that was, I mean, he was pushing it hard. I filled up his tank all the way before we left, and he was just about out. My nephew, who was out there riding with him, was almost out of gas, too. Hey, Frozen, what's up, man? All right, so I got a funny story to tell you. So you might be trying to reconcile how were we out there for only riding for 2 hours if the kids ran out of gas, but we were out there all day. That's because I met this really amazing dude who's very big in motocross, and they were out there working on one of the four-wheelers and tuning it with this stupidly advanced carburetor. All sorts of cool things that you can adjust it with, and it makes it just... it's a dream. You barely have to take the carburetor off to go through and tune it. So we were helping him work on that a little bit. And by helping, I mean, I was watching and learning because this thing was fascinating.
Bullshit, I can't hear you. Sound off like you got a pair.
Frozen, you're so full of crap. Anyway, we got to talking. Dude's an old school hacker type himself. So he and I like hit it off. We were talking about all sorts of interesting stuff. Come to find out his son went into the Navy because he wanted to be a SEAL. Turns out he's kind of on the short side, so he was a little too short to do that. So they asked him what else he wanted to do. He's like, well, I don't want to go into the Marines, so I guess I'll be a medic. And anybody who has served around the Navy or the Marines knows how that goes. For anybody else who doesn't know, the Marines don't have medics. They don't save lives, they take lives. They use Navy corpsmen as their medics. So what did this fool do? He goes into the Navy because he didn't want to go into the Marines, becomes a medic, gets attached to a Marine unit. I just about pissed myself laughing when he told me that. I'm going to go with Rogue on there. It takes 2 hours to empty a tank of gas. Dude, it was because my son and my nephew were out there riding, they ride two-stroke four-wheelers, quads, ATVs, and they were ripping around the track, man. They were getting after it. So it was really cool to see too, because my son, Agent Zero, he's not cornering as good as my nephew. My nephew's cornering and drifting those turns and just taking them hot and fast. But my nephew was a little bit kind of hesitant on all the hills and the jumps. Agent Zero, on the other hand, was willing to jump a teeny bit, but he doesn't slow down on the hills. So it's funny because they'd catch up to each other as they were taking turns or hitting jumps. And so they were just stuck together like two bees, like duking it out. It was awesome. Kid got to learn about the Marine Corps field day and that hell that every Thursday night turns into the barracks. Yeah, no kidding. So it was really a fun time. Oh, let's see. Now, the good news is I actually had a little bit of time to go get the lab spun up, so it's already good. And actually, I fixed one of the issues here. because this was referencing the wrong field to check if it was failed or validated. So fix that. That's actually our exploit step. That's our current step. So actually our current step, I'm going to refactor this real fast here. I'm going to change that to index and then change this one. Just like that. I was a medic in the army, and here's a fun fact for you. The branches of the military, so medic treat the same hold on, I messed it up here. I didn't know you were a medic, Gubby. That's awesome. So fun fact for you, for the branches of the military, so medic treat at the same base at Fort Sam Houston. Is that where they do all the training at, Gumby? Is that what you were saying? Oh, they do all the medical treatment there. Gotcha. Hey, Tom, what's up, man? Let's see. What are your thoughts on Claude Sonnet 4.5? Huge leap over the previous levels in LLMs. So, I think so. I don't have any good way to quantify it, but I'm using Claude 4.5 over in doing other stuff. For this project, we're still using Sonnet 3.7, and it's working out pretty decently. I'm interested in jumping it to 4.5, but I decided to go ahead and leave that as a known variable for the purpose of this testing. Plus, it burns a little bit fewer tokens than 4.5, I think. Oh, so all the training was done at Fort Sam Houston. Gotcha. Yeah. But, Tom, I've used 4.5 for a couple of different things. So I don't usually let the AI do any coding unless a couple of very specific conditions are hit. One is if I'm not planning on using the code very much, or two, if I've just hit a massive problem, I don't know how to overcome it. And so a little bit was used in this project that we're working on in two different spots. And one of them really, I think we used Grok, and it just kind of outlined how this thing should have been structured. And then in the second section, it actually wrote a lot of the code. And the code actually, as I looked at it, I realized it's way over-engineered. So I'll probably go back and rewrite that section myself. I'm writing a book just now called The Spirit of the FBI. It's about cactuses and surveillance. I was expecting it to be more about stingrays and surveillance. Oh, let's see. Did I leave myself a to-do in here? I don't remember what I was doing. Actually, I do kind of remember what we were doing. Let me go pull up... Let's go pull up the graph here. Over in the exploit agent. That is an ugly graph. Good lord here. Let me see if I can... Wait. Why is... Oh, something is definitely messed up here. Hold on. Here's our planner. Here's our step processor. There's the revisor. Oh, things are just completely jacked up. Hold on. Here's our step updater. Oh, here's our exploit tool node. Okay. All the nodes, for some reason, just started rendering all sorts of funky. All right, there's our payload crafter. And there's our tool node there. Okay, so we haven't wired this one up. That's why it looks weird. So if we come down here, the tool node for this, we need to actually go wire this up to talk back to payload crafter. After that, it should help fix this, the graph here a bit. GPT-5 threw me for a loop, so some people claim it's incredible. I had pretty mixed results. I'm not sure if they're A/B testing with the users, but the community is pretty divided on it. I've had last-gen models solve problems that failed me on GPT-5. See, that's what I've been hearing a lot too, Time, is that GPT-5 was just kind of weird. It's a lot of hit or miss for it, like you were saying. Although, to be real, I've been hearing a lot more miss than hit with GPT-5. So, but I've had nothing but good experiences over on the Anthropic side. So that's the one I've been sticking to. Honestly, the reason we started with Anthropic for this one is just because I had $100 in Anthropic credits. That was the main reason why. All right. Hey, Nesto, what's up, brother? I am working on a combined chat thing also, by the way, for you guys, because I know y'all want to see what's going on in the other chats. I'm working on it. I'm seeing if I can get something set up. I've had more consistency with Anthropic. Yeah, that's about what I've been having too. I haven't seen Anthropic go really off the rails. In fact, I had it completely code me one project, which was a plugin for PyCharm, and it was just for my own use. I have no idea what the code is doing. I know what it's doing. I don't know how it's doing it because I don't like Java. So I didn't want to go code something in PyCharm in Java. But it actually went through and it processed it. It made the workable plugin. I was giving it feedback, and it did make something that was usable. I just don't know how good the code quality actually is. I'm a co-pilot. I'm co-pilot mad. I've tested everyone I can. Killed 2 with 1 click. It's dead, Jim. All right, hold on. While I'm thinking about this, so what I need to do is this payload tool node here. Man. Let's see. I need to go wire this sucker back up. So this payload crafter tool node, I need to send back over to the exploit payload crafter, I think. Yeah, let's... Let me think about this. So what's happening, by the way, to catch anybody up who is just tuning in for the first time, we've got a state table. It's just a giant object, a typed dictionary with a ton of data in it, and it gets passed to each of these nodes. So it's like a single book of truth, and we return the updates we're going to make to these to that state table as it gets passed to the nodes. So what I'm thinking here is, I'm trying to think how to actually process this guy right here and how I want to handle this. Because I haven't made any changes to... I haven't made any changes to this guy and how it's going to emit that data back up to the state table. This one is easy enough to work with, but how we're going to actually bring that back over and have it input, that's going to be a little bit weird. Any recommendations on how to start with LangGraph? I don't know when I'd start incorporating it into my upskilling on Python. So you really want to use, if you're going to be using it, you don't have to use LangChain with LangGraph. However, the two of them are more or less designed to work together. So everything that's happening over here in LangGraph, I don't have to use LangChain to pass this. I actually don't have to do any language model calls whatsoever. I could just use LangGraph to do a purely deterministic program if I wanted to. All you have to know is that it's taking that state table object and it's passing it to each node. The node is taking in the entire table, it's returning whatever changes need to be set back into the table, and it's passing on to the next node. So kind of like N8N, but with more coding to it. Now on the flip side there, LangChain is what's actually going through and making the language model calls and bringing them back over. Yeah. So if you really wanted to start with something and use it for tinker around with AI agent creation, you'd want to start with something like LangChain first and then move over to LangGraph. This is going to confuse me a little bit here. Let me go look at the exploit payload crafter. Okay, so in the payload crafter, what we're doing is we're looking at the current step. Hey, Kaiju, what's up, brother? So it's just a diagram drawer if I'm only using that. Not necessarily even, because really every basic function that we've defined in here, we've mapped to one node in this. So as we pass those nodes through it, it's basically taking in that state table, executing the function, and then I don't have a good example down here because we're still working on this function. It just returns whatever fields have changed. So for our state table, we're using this right here, the stinger state. So we have a couple of different fields in that type, and it's just a typed dictionary. So we have messages, we've got our list of hosts, we have our tasks, we've got a tracking integer for our current task, context, which actually really isn't being used right now. I wonder if I could use that. I bet we could. Gumby, I'm right here, dude. I'm not even pooping. Well, let's see. All right, so Kaiju is asking, what would you say are more substantial differences between Portswigger and Hack the Box? So I'm assuming you mean the Portswigger Academy. And the difference there is the Portswigger Academy is designed to teach you with some challenges, but they're not like CTF challenges, how to do web offensive security testing or just web security testing. Whereas Hack the Box is you're given an entire system to go test. So instead of just a web application on that box, you've got the entire system, and you have to typically compromise some kind of a web application or maybe use an exploit for a listening system to get on that box and then elevate on it. So the difference is one is very focused, just the web stuff and all the attack patterns with that, and the other one is a bit more freeform puzzle solving. Really, that's what Hack the Box is. It's Sudoku for hackers.
Hack the planet!
Hack the planet! Let's see. I got a Raspberry Pi Zero W Ponagachi fully running with WaveShare Paper Hat. Oh, nice. It's got the face and body of a Pikachu. Oh, that's awesome. I had one of the guys at work who really liked his Ponagachi. I thought about making one, but I was like, I don't know when I'm ever going to go play with it, honestly. For anybody who doesn't know, the Ponagachi was the idea of taking a Wi-Fi, basically portable testing kit made on something like a Raspberry Pi, and putting a paper, an e-ink screen on it, and then treating it like a Tamagotchi. So Evil Socket, when he created that, he called it the Ponagachi. I'm 99% sure that was Evil Socket's project. That was the developer's name. Oh, I did leave myself a to-do here. Find a way to track updates to the initial access exploit to allow iterations. Actually, you know what? I just realized something. I left this context value in here just as a just in cases, right? But we never put anything in it, ever. We just don't use it. It was in there because I was trying to figure out how to do the context handling. But like if I drop down into here, right? If I just collapse all this down, our context, actually I take it back. Our context has one thing in here, the target machine IP address. That's it. Okay, I think I'm gonna have to expand the stinger state, which sucks because that means what I have to do is go to expand the stinger state. I have to do another seed run because it's gonna change the entire state table as it flows through the system. So I like the context idea. I don't want to mess with it just yet. Next, we could leave it here. Damn, this is going to suck because I got to rerun it all. But that's fine, because what we can do is we can actually come over here to... We have to rerun the entire stinger run. But when we do this, we can expand the exploit graph, and we can tell it to break on... Oh, come on. Oh, come on. What is going on here? Here. Hold on, let me reset the zoom real quick. Reset. Okay. Yeah. You're not gonna let me break on this one? Really? Come on. Come on, man. I can't interrupt. I can only interrupt when leaving the subgraph. Oh, that's a bummer. Okay, I'm gonna have to send that to the LangGraph guys. Because typically, like, hey, if I hover over this node, you probably can't see it. Hold on, let me zoom in the page here. So when I zoom in on this guy, you see how I have interrupts I can do before it enters or exits the node? That's cool, but exploit is actually a subgraph. It's its own agent, right? And so I can't interrupt as it gets to these other ones right here. That's, I think, a flaw in the design, but whatever. It doesn't cost us much. It's gonna crap out as soon as it hits that. I think I just broke it. I spent 389 pounds on this one to upgrade it to the Pi Sugar with a 1200 milliamp hour battery. Oh, nice, man. Oh, you're talking about it's showing invisible connections to your original SSID? I mean, if you're not broadcasting your SSID, yeah. Eventually, you can decloak that SSID, though. So, cloaking SSIDs used to be considered a best practice. Now it's not really because the process to decloak it's really simple and get the SSID back. So now it's more of an annoyance than anything. I'm officially excited about programming now, so I've been a big fan of dill pickle since I was a kid, and this program loads pickles. The pickle is just a dirty hack in here. Hold on. So what it does is this is an example of, like I said, this could just be a pure function here. It doesn't have to make a language model call. But what it does is it comes over here and says, it checks the state table when it gets passed to it. It says two things. If the state table is empty, load the pickle from disk. So basically a serialized copy of that data structure, throw it into memory. Or it says if the state table has data in it, then take a copy of it and throw it onto disk. So that way, once we run the seed run through Stinger, here, like I'm about to redo, once this happens, I don't have to run the entire graph and go through recon and enumeration. I can just come to the exploitation agent and run it by itself. So it's a poor man's time travel, basically. Running the Just Call Me Coco firmware. See, I'm not familiar with all the different firmwares on the Ponegachis. Somewhere around here, I've got my, what's it called? My Flipper Zero, and I had it running a custom ROM. I just don't remember what it is. I remember it being a pickle. I, too, was once a pickle. Yeah. And then, unfortunately, when I was a pickle, I made the mistake of standing in line, and then I turned back into a cucumber. Sorry, that's a really bad line. All right, I'm going to do this real quick. I'm going to take the Stinger state here, and we're going to expand it, which unfortunately means we're going to have to run another one. So I'm going to call this... That's our context there. I'm going to call this our... I'm going to call this our working memory. Let's see. Stop it. And this can just be type any in here. And the reason for this is because what I'm going to do is I'm going to use this inside this particular agent, right? So the idea of working memory, let's put a note here. Only used for internal agent information. Actually, I should say internal primary agent information. Because what I'm thinking about doing is we're going to use this, and since we can throw anything we want to in there, we could even make a tiny state table and throw that sucker in there. Because we need something to persist and to check when we're in the exploitation agent. Oh, there it is. I was like, where'd it go? Because what's happening here is we have our payload crafter, right? So after we come over and we finish this whole loop of crafting the exploit, getting it up and running, we actually need to craft the initial access payload. So when we do this, this guy should come over here and take all this information and say, okay, I need to actually make the initial access exploit that is repeatable based on the information that was given here. And then it needs to be able to basically iterate over itself back and forth, right? So when that happens, we need a place for it to store information. So we can have it do that in this working memory right here. Like I said, the downside is, however, I need to go get the test data again. Oh, by the way, I moved the testing data out of Stinger, by the way. It's now in testdata.json. So I finally decided to migrate that. In fact, I'm going to go do that commit real quick. So these two, I'm going to get committed. Let's see. Let me make a note of that real quick. Moved testing state information. Info to, what did I call this? Test data.json. There we go. Commit that. Okay. There we go. We'll push it later, but I'm going to go ahead and commit just that one change real fast. Hey, Simply. What's up, dude? Oh, your Marauder ESP32 is running the Just Call Me Coco. I got it. Get it. All right. Let's see. Simply said, take a look at this working on speaking at DEF CON next year. Nice. So it's a fuzzer specifically from memory or for memory vulnerabilities via CPU branch attacks like Spectre. Dude, nice. Hang on one sec. Let me check a look at that. Dude, you're always working on such awesome, like, low-level Linux stuff. I love it. Very cool. Check this out. I also appreciate good ASCII art. So where you are in userland versus the kernel versus your KSLR, your address space layout randomization in the kernel. I'm assuming, I'm pretty sure that's what it is. Nice, man. I gusta Sinbleed. If you get that talk approved or you want somebody to read over it, I would volunteer to do it, but honestly, you're doing stuff that's way beyond my skill set in that area. Yeah, that'd be awesome if that gets accepted for a talk though, bro. Let me know. They had a pretty great talk on firmware hacks this year at Black Hat. Nice. Nice. All right, let's go run Stinger while this is doing it. Did I update that? I'm questioning myself now. Hang on. 36147. Okay, I did. Awesome. Let's copy that. And let's go run. We got to do a full run, unfortunately. That's okay. I didn't need all those Anthropic tokens. It's fine. This is fine. Everything is fine. We're just going to burn those tokens to the ground. All right, there we go. So Recon's running. I really think I need to clean up how the in-map stuff is working. Yeah, I think I need to make some custom in-map output information here. Because I think the Recon output formatter, I think if we have a special case for it to handle in-map output and then a generalized case for everything else. And the idea was we would go through and we would create output formatters for specialized tools. Actually, I had a pull request over for RoboPages to be able to push output stuff so you could use something like Pydantic to send the data and the Pydantic model up to the language model and have it self-extract all that and format it for you. But unfortunately, the guy who wrote and was maintaining RoboPages, he left Dreadnode. So they don't have anybody to go maintain the code base because he wrote it in Rust. Freaking Rust. It's like, you couldn't have picked Go or freaking Python or anything. You had to write it in Rust. All right, there we go. So enum's running. I'm going to manually kill it once it gets down to the exploitation agent because we're working on that agent. We don't need it to do anything right now. We just need the state table to get updated for the new structure. What is it running right now? It's probably running GoBuster because that's part of the enumeration process in here. No, it's running the Katana headless crawler. That's not good. What's it doing? Examine the discovered directories to see which ones have upload forms. Oh, that'd be interesting. I wonder if actually that will work. Let's see if Katana actually recognizes that. This is also what I was talking about with filtering and renaming all these tools. So see, we've got all these various tools we're going to do in here. So we're going to go through and actually filter this stuff out so that certain tools are available all the time. We'll call those like generics. But then also we'll have some that are specified like, hey, this is just for enumeration. So, for example, we don't necessarily need... actually, these will all be fine for like enumeration, but like SQL map, we're probably not running that for enum. Maybe. You can do it. Oh, there, it died on its own anyway. Perfect. Because once it hits the step revisor, it's probably going to die. Yeah. Is that where... No, wait, that's where it failed. Hang on. Let me refresh this. Huh. Where did it say it died at? Let me see. Because there's certain areas I expect it to die because we're working on the code, and there's other areas I don't expect it to die. Oh, okay. This makes actual sense. So it didn't do a proper return. The exploit step planner came back and it didn't do a tool call. So when it hit this, it just completely crapped itself. So what did it say? So we told it to upload a... So we have it, it's got the system prompt up here, but the task was upload a PHP web shell to the panel directory and access it through the uploads directory. So this is the exploit planner, right? It should have gotten this. Oh, it did. Hold on. So what's the exploit step processor? What did it do? Its thing. Oh, let me back up real quick here. Hey, B44, what's up, man? Am I blurry? Ah, that camera. Hang on. Yeah, the camera's stupid. Sometimes the camera just decides to eat itself. I don't know what causes it. Let me see if that fixes it. Nope, there's my hand though. What the heck? Nope, that didn't do it. What happened here? Hang on one sec. Let me do something here. Let's do that. Let me switch here. One sec. Stand by. No, I gotta find the... There it is. Hang on. Why you do this? Why are you acting like this? Piece of crap. I'm not pooping right now. I'm right here. I'm working on the camera. Let's see if it comes back now. Hang on. Now, what's it doing now? Okay. Why are you being stupid? Why you gotta do this? See, did that fix it? Nope. Sure sounds like an excuse for pooping. You guys know I don't have a wireless microphone. I'm not just sitting here crapping through the mesh on my chair. Now, what is this damn thing doing? There it goes. Okay. Alright, let me try this now. See, did that fix it? Hey! Now we're talking. There it goes. Piece of junk. I've been meaning to get a better webcam anyway. Now, what was I actually doing before 44's like, hey man, you're all blurry. Let's see here. Oh, that's right. We were working on this. So what we're going to do is, let me come back over to the state. So we're going to start throwing things over here in the working memory, right? So how do I want to handle this? So we're going to make a call for our payload crafter over to this guy. Find a way to track updates to IAE to allow interactions. Okay. I think what we're going to do is, we're going to change this note. We're going to say, track IAE in state working memory. There we go. Boop. There we are. He gonna call Ghostbusters. It'd be an adventure to learn how to have a transparent background for live streams someday. It's a cool effect. It's just there's a green screen back here, and I've done a little bit of crafting in OBS, so the camera is always on and the green screen is always applied. And then this is just hiding the scene where the camera is nested. So it always stays on, it always stays transparently rendered. When I first originally was doing that, you'd actually see the green screen like blip into existence for a second, and then it would turn on the chroma key. Yeah, there is a green screen back there. So if I don't think I can turn it off right now. I can't. I don't have the shortcut in here to do it. But yeah, you can. You can do a green screen back there. Let's see. All right, so how we're going to track this is, let's make us a little, we got to make us something to track this with. So I think what we're going to do is over here in working memory, we're going to say state, and we're just going to access it directly. We're going to say working memory. And we're going to make it kind of like this, our messages right here. Yeah, we'll do this. We're going to make this little key here. So we'll have a second set of messages in here like this. And what we're going to do is we're going to put response in there, I believe. I'll have to double check that, because that should give us like all of our messages from that. Yeah. We're going to do it live. That's right. Oh, yeah. Not sponsored by Jocko. Transparent Jocko. Yet. I needed that, though. Today was not a hard day, but it was a long day. So what else I need to do in here is, we actually need to come add a check first. We're going to see if we need to have working memory going into this. Actually, let's add a new object into this. So what we're going to do is we're going to say working memory. We're going to call this, we're going to say this is the caller. And the caller is going to be the node name. Hey, Akshay. I almost read that as Akshay. But anyway, thanks for coming online, man. Welcome in. All right. So I'm going to just set this as the function name right here, because then we can say, okay, this is the one who's actually doing the work, the exploit payload crafter right here. Messages is going to be response. Let me put a little comma right there. Okay. This way we can keep track of whose working memory we're actually looking at. So what we'll do is we're going to set us up an if loop here. So we're going to say if, let's see, state, no, that's not right. So if the state's working memory, let's see, and then we're going to get the caller. Actually, I do want to go ahead and I'm going to make this a little bit more rigidly defined. So what I'm going to do is I'm going to add one more thing in here. We're going to make a new class. We're going to get classy with this. So class, we're going to call this working memory. That's right, Nesto. We're going to get crazy with it. We're going to make this a. Actually, how did I do this before? Let me look at something real quick. Yeah, we did this as a typed dictionary too. We did an annotated type. Okay. Yeah, we're going to do that. So we're going to make this a typed dictionary, just like this. And what we're going to have is we're going to copy this messages key right here, because that's going to allow us to keep a message queue for just this small subset of information that's happening. And then we don't need to keep it forever. We can blow it out of the water if we need to. So we'll have working memory. We'll have some messages in there. We're going to actually have one more before the messages. We're going to have the caller. And this is going to be string, just like that. And then we'll have a data object in here. And data can be type any in this. And then when we do working memory, this is going to change. We're going to change this to a type of working memory, like that. Boom. Now we're talking. CyberRat, thanks for coming online, man. Welcome in. I hope you guys are all having a fantastic Saturday. No, it's Sunday. My days are all jacked up. I hope you're all having a fantastic Sunday or Monday, depending on your part of the world you're in. I love the dial-up too, Nesto. It makes me so happy. It tickles my little nostalgia berries from my brain. Future BlaiseBit sponsors. Jocko, Chips Ahoy, maybe Jimmy John's? No. Jocko, yes. Chips Ahoy, absolutely not. I actually did not eat carnivore today like I usually do. Because of the chance I had to go meet with that other fella, we went to Denny's. I had pancakes.
Incoming transmission from Reach Chris Young. I hope I never have to hear about your tickles again, lol.
Well, good thing I'm not an octopus, Chris, because then I'd have 10 tickles. Sorry. Not sorry. Yep, I went there. Let's see. Caller, message, and then data. So let me initialize this guy right here. Data value. And then that's going to be, what do I want to call this? We'll just leave it as like a blank dictionary for now. So if there's any pieces of information we want to store down in data, we can. I think we'll be good with just messages. We might just be able to leave data blank. And of course, we're just cramming more into the state table. Thank you for the biddies, by the way, Chris. Okay, cool. So what we'll do, we do need this. What we're going to do is we're going to check this calling memory. We're going to say if the working memory caller equals our function name right here. No, not like that. There we go. So this equals our function name. Then we're going to basically, I'm going to put a note in here, continue the crafting loop. I don't know why I'm having so much trouble typing lately. Continue crafting loop. And then we're going to do an else in here. We're going to actually set the working memory to blank right here. And how do I want to do this? I'm going to put this in context helpers, but what I want to do is set that to a, we're going to basically do a blank working memory in there. So let me go find the context helper real quick. Yeah, let's come down here. We're going to define, I don't want to do this. Yeah. Dr. Reiki, what's up, brother? Happy Sunday, man. Well, I'm a little sunburned on my neck, actually, from being out at the track all day. But man, the kids were they were ripping around there. There was one other kid there. So Agent Zero is about to turn 7. His cousin, my nephew, will be turning 7 in 2 months later. They were born very close to each other. And there was another boy there who's 10 or 11 years old. So Agent Zero and nephew have a faster bike than the older boy, right? Agent Zero can handle jumps better than nephew. Nephew can corner better than Agent Zero. The older boy is an all-around better rider, though. So the three of them were all keeping up, even though he had the slowest bike of the three, because he corners and jumps way better than them. So it was really cool to see the three of them like a roving pack of marauders going around the track. It's 40 degrees there, man. Dang. It was a very nice, like, 70 degrees here. Let's see. I'm going to call this, get new working memory. By the way, Dr. Reiki, so as I looked at, remember the issue I was talking to you about up in Seattle with the Python code and the async. I think I totally don't even need that. I'm gonna rewrite that whole thing that Claude spit out. Let me make, I think, one more change here. This should return a... Actually, I gotta check the imports here. States, yeah. Actually, I need one more in here. We need a working memory. There we go. Because this is gonna return a working memory. Right here. And then all it's gonna do is it's just gonna return a new type dictionary or caller. So we'll say caller is just going to be an empty string, and then we're going to say messages. It was in 70s here in Arizona. It dropped to 57 last night. I'm surprised it only dropped to 57, but then if depending on where you are in Arizona, you could have a lot of concrete holding that heat in. Let's see. Messages, I think I could just make that a blank list. And then we need one more thing here, which is some data. And for now, we're just going to, and in fact, that needs to be like this. Oop, I'm missing all of my formatting. There we go. That's not correct. There we go. So all this is going to do is just return this information back to us so we can use that over here. So now what we're going to do is we take this out. Working memory, we're going to change this. This is no longer an if statement. We're going to set this equal to get new working memory, just like that. Boop. Yeah, I just remember if I had told you about it though. By the way, I got another buddy that I made. So next time you and I are up in Seattle, I got somebody we need to go hang out with. Oh, you liked the memes that were in the blog post? I'm glad, man. One of my buddies, he sent me that. He's like, hey, I was going to read your blog post, but it's too damn long. So I just skimmed the memes. I'm like, honestly, you can get most of the valuable information from the pictures. Just to be perfectly honest. Okay, so I'm going to make a note here. Init new working memory. So this is going to be our branch where if we already have a working memory, we're going to do stuff up here. Otherwise, we're going to prepare stuff down here. So this is, we're going to say start new loop. Start new crafting loop. Boom, just like that. And then most of this stuff here, I believe, should come up into this branch right here. So we're going to tab all this up real quick. I'm going to go ahead and delete this for now. Actually, no, I do want that. I'm just going to leave it as it is for now. So let's think about this crafting loop. Actually, there's one more thing I got to go fix, if I remember correctly. We haven't looped this back. Yeah, so the payload crafter is not looped back over to the tool here. And so this tool should not be going to end. So we need to go add a new edge from this guy. So exploit payload crafter tool node back to exploit payload crafter. Okay. So let's go add that edge real fast. We're going to edge a little bit. I'm sorry, not really though. Let's see. That's where we added the node. That's our payload crafter tool node. Oh yeah. So actually, let me come back here. I'm going to add the edge up here. So exploit workflow. We're gonna add an edge from this one, and this is gonna go from our tool node, and then we're gonna send that one over to our payload crafter. So like that. Now, stop it. Stop being helpful. There we go. So now if we save that, when this hot loads back in, actually, it's probably throwing an error right now because this if statement up here is probably blocking it. Just S, like that. There we go. I just want to see it render the graph, so I had to put something in there for it. God, this is so ugly, this graph here. It doesn't know what to do with it. Okay, so there's our handoff stuff. There's our exploit validator. It's trying. It's trying so hard, and it got so far, but in the end, it did not even matter. All right, let me bring this about like this. Okay, that makes a little bit more coherent sense. Let me drag that off to the side. All right. So what should happen here is we get the exploit agent. It says, hey, we want you to go do an exploit against this target. The planner says, okay, here's what we're going to do. The processor goes through the loop. Once it has completed the exploit, all the information of everything that was done gets passed up to the crafter. The crafter should basically be executing in a loop right here, and trying things out, basically building it. And once that is done, it should hand off to the exploit agent. We don't have an option in here for this to fail, though. So don't fail. Actually, it'll auto-fail if it gets really stuck in a loop here. It will eventually say, I don't know what to do. It'll just fail out. But that's actually okay, because what we can do is we get this new working memory. We're going to add stuff up to it, like our response and whatnot. Actually, I'm going to bring this in here because this does need to be in this loop up here. So we get the response back. We're going to add the response here, but we're also going to, once we hit the exploit payload crafter, what are we going to do here? Let me think about this. So once we hit this, we need to, this new working memory thing I'm having to think about since we literally just built it and how I want it to work. I got an idea of how I want it to work. I got to make sure I pinpoint it in here. So we craft it, we craft up here. Actually, there's one more thing I want to do with this, which is, first thing we want to do is we're going to go into the working memory and we're going to have a field in the data here. So yeah, let's do that. So in our data for this working memory right here, we're going to check this real quick. I think could this work? Yeah, I think it'll work. So what we'll do is we're going to check in the data. We're going to have a value in there called attempts, like this. And I think I want to set that to, I think I named it to max step retries. We could tie it to that. I'm going to hard code it for now. So we're going to give it 5 attempts to go through this. No, we don't want to do that. This would just be, we want to increment that value. Plus, plus, just like that. Wait, does Python not understand plus, plus? Plus equals 1? Ah, there we go. We could do that.
Incoming transmission from Marano Gumby. What is this for?
So what is this for? We need something to track in the state table that as the exploit payload crafter, it's taking all the information from the exploit loop, right? So it's gone through and it's made its calls, it's done its revisions, and it's come back to here, right? So what we need is we need a place to track all this information that's happening. So the working memory is now going to be a small dedicated section of memory, basically in the state table. Persistent data that we could pass to other nodes or other agents, but we don't need to. So we're going to kind of define boundaries in the workflow that, hey, once it hits this part, working memory is suspect at best. So that's why we have this check right here, where if it equals the exploit crafter, then we're going to say, okay, cool. We're going to start working under the assumption that we have data in the working memory. Otherwise, first thing we do is we nuke the working memory and we initialize it basically to blank. So we knock this sucker out. Hey, Bobby, what's up, dude? Happy Sunday. I do like Sundays. Sundays are good days. Honey Badger was especially happy because since Agent Zero and I were out of the house the entire day, he got mommy all to himself and didn't have to compete for attention, which really works well for him. All right. So let's go down. I'm assuming that we're going to have it do multiple iterations of tool calls. So I gotta shorten
Incoming
that a little bit.
transmission from Mariano Gumby, so you reset the memory and start from scratch.
Yes, sir. So because this guy is going to be executing this loop here, so we wanted him to have working memory for this section, right? So one thing that where this wouldn't necessarily work so well is, hey, if we had this kind of going on through here. Now we're still going to take the messages from like the language model call, and we're still going to emit those to the primary state table up here, like into messages. It's just we wanted to have a spot where it wouldn't contaminate the data, and it had this little tiny chunk of memory that it could work with. Something that's completely set aside. Think of the state table as long-term memory, and the working memory is our short-term memory. It's designed to be used and then boot it out. And then when we hit the next section where we need it, boot it out, reinitialize it, use it however we need it. Yeah, I think that'll work. Because what we want is we want the exploit payload crafter to be able to keep track of what it's done so it can make its own revisions.
Incoming transmission from Mariano Gumby. Okay, I'm tracking.
I'm glad, man. The little transmission sound cracks me up. Let's see. I had to change it to like the old AOL sound from like AOL Instant Messenger. Good old AIM. Let's see. What is this going to return actually when we do this? Yeah, it just actually returns an output value. That's right. Yeah. So when we get this back, that response value, we're going to have to... So we do want to update this tracking data. You guys, ever since y'all figured this out last night, y'all been patrolling me with tiny
Incoming
messages.
transmission from Mariano Gumby. You should totally do that.
Or the you've got mail from AOL. Dude, I get so sick of that. I changed it when I was a kid, right? I had AOL, and I changed that stupid message to you've got spam. My dad didn't appreciate it. Yeah, right, TTS abuse. Eventually, I'll probably put in a queue like what some of the other streamers have, like pirate software, where it tracks it. Actually, I've already got something set up now where it will track those messages over to Discord. I just need to go modify the code. It wasn't written by me, but I found it, and I've been testing it, and it's been working. So, like, when somebody does a cheer like that, they send a TTS, or if they redeem points, like a floppy disk, then it keeps track of that. If I ban somebody, it keeps track of that, which thankfully doesn't happen very often. I like it. Everybody coming in. Let's be chill. Everyone chill. Let's see. So we're going to continue the crafting loop. Actually, there's one thing I need to do here. So we want to go set this in our working table here, our working memory. We want to set attempts to 0, just like that. Sunday chill stream. That's right, Ernesto.
Incoming transmission from Mariano Gumby. Ban me, daddy.
Don't do that. Don't do that. I have to show y'all something, actually. Hang on. Because you just reminded me. Yeah, here it is. Hang on one second. I have to show y'all this real fast. Because this one cracked me up. I hope it's going to be at a good volume. We'll see. Wait, is it muted on here? Hold on. Oh, I had it.
Begin.
Hang on.
All right. The pact is sealed, my beloved warlock. Now rise and begin your submission to me. Don't do that.
Yes, mommy.
Don't do that. All right.
Oh, that cracked me up. Yes, mommy. Don't do that. Don't do that. Oh, freaking D&D memes. They crack me up. Where am I hearing myself now? Hold on. Something got unmuted. Because I've got stream monitors up, so I'm keeping track of, like... Hang on one sec. I gotta figure out where I'm hearing myself from now. Yeah. Alright, there we go. One of the stream monitors got unmuted when I was playing that. Alright, so here we set the attempts to 0, so we initialize that.
Incoming transmission from Marano Gumby YouTube playback.
It was the YouTube playback, yeah. One of the YouTube monitors, when I unmuted that, it was playing back on it. It unmuted, like, the monitor page. Which is weird, because it wasn't showing it as unmuted. Anyway. Alright, so here we're going to set the attempts to 1. We're going to basically use this same kind of setup here. In fact, let's go ahead and I'm going to move some of these, like the exploit task, the parent task, and our context. I'm going to move all this stuff outside of this loop real fast. Is this how I want to do this? Yeah. I'm going to move these up here. So we'll initialize these values out of the state table real fast, and then we can use them down here in the loop. Love you long time, Gumby. One of the bots got unbotted. I know, right? Let me think about this. So let's look at the initialized one. So we come down here, we set up the new working memory, we initialize our attempts, we set up our payload information, and then we make our language model call. So we can actually go ahead and take this up also. So we can take that and we can move it up here real fast. Move that outside the loop. You take this out. Don't need that anymore. If I wanted to get down and dirty, what I do is I would take these responses and just append, or I just append the working memory's messages to it and let it go through like that. Right now, we've already got it giving the context to it. We'd have to go add a separate section to that. Let's see, we already got the context being prepared, then we get our template being prepared. So all that is good. We could go add that up here, potentially. Now, I don't want to mess with the working memory outside this. So in fact, I'm going to just call this the working memory loop. Let's see. Ronking. Working memory loop. Right here. Because there's a chance it could just get it on the first try here. So for our working memory, callers, messages, data. So any particular data we want to store in here. Let me double check something. I need to double check the prompt that we're using. So our exploit payload crafter template. Let's go double check that prompt real quick. So we said tool calls may be provided to generate the initial access exploit. Yeah. This is going to be a pain. Actually, I'm going to put one more instruction in here because typically as we build this for doing these, like for example, for the web shell, right? We've got it in here. So I'm going to put one more directive here. We're going to say tool calls should take the highest priority. Should take the highest priority. And then we'll do one here. Actually, I need that there. Let's come back here. So we need to add another instruction though. I'm gonna change this real quick. Specialized tool calls. Yeah, specialized tool calls. Actually, I can take this part out. We don't need that in there. Tool calls should take the highest priority. We're gonna say, because the other thing it could do is it could go generate Python code to pass that up to, but it also then if it does that, it's going to pass it to the Python executor. Actually, yeah, I do need to put one more thing in here. Let's see. Initial access to create the... I'm going to change this. Instead of just creating it, we're going to say to create the code for a... Your job is to create the code for an initial access exploit to the target based on the information context. The initial access exploit must be a repeatable command that executes at least one system command. Specialized tool calls may be provided to generate the initial access exploit code, because we wanted to get the point that this should be code in here. Tool calls should take the highest priority. Okay. So there's one other thing we could do with this, and that is we could structure the output from this. We're not doing it currently. Damn, I hadn't thought about this part of the exploit agent because we were stuck in this loop for so long. I thought, oh yeah, cool. Once we get that done, it's like, well, crap, how are we supposed to get the exploit payload actually legitified and solidified so we can put it over into the state table? So that's what this loop is supposed to do here. I'm trying to think, do I need to expand this prompt any? I'm trying to keep the prompt skinny until we run across certain conditions where we can then break them out, generalize them, and then append them to the prompt. So the initial access exploit must be a repeatable command. Let's see. That executes this. Tool call should take the highest priority. Actually, I'm going to say repeatable Python code. At least one system command. Specialized tools may be provided to generate the initial access exploit code. Tool calls should take the highest priority. Actually, yeah, that's not important. I'm going to take this out. If you need to generate the code, great. Actually, yeah, because I need to tell it, basically, I need you to create simple code that doesn't have a ton of Python libraries to come import, because it's going to be executing over in robo pages, and so the Python executor only is going to have the basic thing. So let's say generated code should only use standard Python libraries. Let's do that. Standard Python libraries. I can't type. There we go. Python. Take that out. There we go. So we wanted to only use standard Python libraries. Let's see. Let me change this language here a little bit. So right now we've got to say specialized tool calls may be provided to generate the initial access exploit code. May be provided. I'm going to say to produce pre-generated. There we go. So specialized tools may be provided to provide pre-generated initial access exploit code. Let's see, generated code should only use standard Python libraries. And then what else do we want here? We're going to kind of mark down this a wee bit also. So it understands these are individual instructions. Anything else I need to throw in here? Let's see. Generated code should be validated. Should be tested with Python execution. What was that tool actually called? Crap, I forget. What did we call that? Hold on, I can tell you in just a second here. Let me see. This one. If we look at this tool called Python exec. So we'll drop that in there. No, not like that. Python exec. There we go. So generated code should be valid. Instead of validated, we'll say tested with the Python exec tool. All right, I think that will kind of work in here. I'm trying to think, do I need to add anything else in here? So we've got task, we've got context. Yeah, what we can do is, in that context, we can include everything. So right now when we generate the context for it, right? What we're doing is, we're basically saying build exploit task context, and then we can have all the previous messages included in here. So for the first pass, we want to have that context in there. For the second pass, what we want to start including is all the response messages in there. Yeah, I think that will work out pretty good. So we're going to continue the crafting loop. Let me make a note in here. So for this one, we're going to use, let's say we're going to use full exploit context at first. And then up here, what we're going to do, let's put a note here. Use message history, which includes that context. Previous context. And if that's the case, we don't need this to actually be up here. This context one, we can actually bring this down to... Yeah, because we're going to use it down here. We can actually bring this right here. So this is going to get us the full exploit context. So what it's going to do is it's going to look at all the steps we did, and it's going to take all the data from those steps, format them together, and send that. Now, what happens is that actually gets tracked as part of the messages queue, so we should have that in our history. Are you any good with fstab? Not particularly. I always have to look up a lot of stuff around fstab, which is the file system table, if anybody's wondering, over in Linux. No, I always have to do a lot of man page reading anytime I have to deal with fstab Gumby. Although, if Sinbleed is still in chat, he might know, because that dude's a wizard. Let's see here. So here's our working memory. Messages, data. We don't have any data just yet to throw in there. Are we going to need that data? I don't think so. Would you say transformers are the hardest part to understand when it comes to the large language models? Yeah, because they're not really intuitive, and even if I was looking through the math, right? So that blog post really was like the gentle crash course to language models. So there's very little math in there. There's talking about some math concepts, but I didn't really actually throw a lot of math in there because I realized a lot of people don't have that level of mathematical understanding. I have a much higher level of mathematical understanding than, 99% of the general population. Even I struggle with it a lot. I'm looking at it, I'm like, damn, this gets dense really quick. So really the transformers, or the transformer architecture dealing with the attention heads, once you realize that those attention heads basically boil down to like special pattern recognizers, and you can have a ton of them, right? So the example I used in the blog post is GPT OSS 20B. That one has 64 attention heads to it, and that's a tiny model, right? That's only a 20 billion parameter model. You're not even talking like, let me see, I'm curious now. Let's see, GPT OSS 120B. And we'll say, let's see, how many attention heads does it have? Okay, so even the 120 model has 64 attention heads right here. Let's see, what about DeepSeek? Let's look at that. How many attention heads does DeepSeek R1 have? And see, like DeepSeek has 128 attention head layers in there, or attention heads. Boom. And that's per layer. You have to remember, right? So the attention heads are actually per layer in there, and there's 61 transformer layers. So it'd be 61 times 128. So a lot of attention heads that kind of happen in there. The difference is they process each layer kind of individually, and you can think of it like it's paying attention to certain things as the layers progress through it. That was the best way I could think to understand it and try to relate that information. But yeah, the attention heads are definitely weird in how they operate. I don't know if anybody truly understands exactly what they're doing. I mean, outside of the mathematical idea, yes, but the idea of like what emerges from the training process of a large language model and then translating that over, because those attention heads aren't set. The pattern recognition that they do as part of the feedback process and the error correction with the cross entropy loss, it just emerges what each attention head does. So if you took the same model and you trained it 2 or 3 different times and you're using a little bit of randomness in there, those attention heads could learn different ways each time. Or if you just use different data as it's coming through there, or the data in different orders, you could potentially have those language model heads working in different ways. It's the way I understood it. I could be completely off base. There's probably some PhD out there who's like, wrong. I wouldn't be surprised. Let's see. So we start the new crafting loop here. Is there anything I actually want to go put in the data? So the data is just for general holding. So we append this over to here. All right, there's one more thing we're gonna need to do with this, and we'll take out this right here. We are gonna actually, let's go ahead and start formatting the return statement to this. So for our return, we format this according to our state table. So we are gonna return some messages in here. So that'll be the first thing. So messages, let's see, we're gonna just return response from this, right? Yeah, one thing we'll need to check up here. Let me make some more notes real fast. So we'll also need to, we're going to check if the IAE works. And if that works, then we're going to add it to our, what are we going to add that to? Add to the host table. So we'll add that over to the host table right there. Let's change that to target host right there. We add that to the target host table. We'll say else. Then what we're going to do is make another pass, just like that. Dude, so Reiki, I was talking about that with so my, for lack of a better term, brother-in-law. It's my sister-in-law's husband, because it was my nephew that came with us, and he was riding with my son and my father-in-law. And so the three of us are in the van, and we're talking about AI stuff. And I was telling him about this, and I was talking about the Transformer model. And Agent Zero pipes up, "Oh, I love Transformers. They have Transformer math?" I was like, "Slow your roll, kid. Slow your roll. Daddy doesn't even know how it works. You get a long time before you get that. Let's make sure we've got multiplying and dividing down first. Then we can work on Transformer math." Oh, he's so funny. Okay, I think that will kind of work here. So let's say, so we start the loop. We start the new crafting loop. We get new working memory. We set our attempts to 0. We're going to increment our attempts. How's this router going to work now that I think about this? I got to look at that routing function, come to think about it. Oh, here we go. So if we look at the last message, if it contains a tool call, then we bail out. Okay, let's do one more check in here. Yeah, what we're going to do is we're going to try this for max steps retry. So first thing we're going to do is we're actually going to go check this value real fast. Oh, we're going to have to return the working data in here, come to think of it. You're not going to let me return the response, are you? Damn it. Autobots, transform and roll out. They do like the Transformers. So, I got to tell you, give me one sec, guys. I got to run to the bathroom. I'll be right back. All right, I'm back. That's right, Gumby. You caught me. The fastest pooper in the West. Let's see. I need to update the working memory here. And we're going to send the working, we're just going to emit the working memory back over to this. Boom, just like that. Let's see, responses. That's not going to work. So this works because the state table is outside the scope. Our response here is not going to work. Actually, we could use the working memory, come to think of it, because we have our messages right here. That's a dirty little hack, but you know what? I'll take it. You're not hacking, you're not trying. There we go. Ah, hold on. It's the wrong key. Messages. There we go. Just like that. So let's think through this real quick. So we're going to have, for the initialization of the loop, right? So we hit this one first. We go ahead and set up the working memory. We build our context. We make our LLM call. We only pass to it the tools that are for initial access exploits. So that'll work. We get our response back. Hopefully for this simple case, right, what should happen is it should see that we have a function for getting the initial access exploit, right? So if we come back over to the tools here, right, what we've got is we have a tool literally called get PHP web shell diceco initial access exploit. So the reason why I have been typing that out the whole time, initial access exploit, is because those group of tokens should kind of create like an anchoring vector, more or less, in here, and then point hopefully everything in the right direction. So for example, eventually I expect to have calls in here for like different things, like for C2 implants, right? So we'll have tools in here for going and getting C2 implants or just other types of artifacts in here. So in this case, we're using a particular type of web shell, but anything else. So for example, if we don't have a PHP web shell, right, we might have an ASP.NET web shell. So then we go make the same set of function calls for that. So we have a call, one to actually get the artifact, one to actually call the web shell, one to actually get the initial access exploit to make it reproducible. HTTP get in post. I think that'll work. Not sure if there's a place in the system prompt, but I've had some success with adhering to the 4 C's of effective prompting, which include make it clear, concise, contextual, and consistent as an output requirement. So basically you tell it those are the 4 things it needs to be. You tell it to be, you literally tell it in the system prompt, be clear, concise, contextual, and consistent. Because honestly, I haven't done a ton of reading into context engineering. Done a lot into context breaking, or not context, but system, like prompt breaking. Always be. You know what? Just for you, Bobby, I'm gonna try that. We'll see how it works. So far, we've been having a fair amount of good luck with the prompts and how they've been for as little as they're engineered. Let's see. Always be clear, concise, contextual, and consistent in output. How would I word this? Well, it'd help if I spelled consistent correctly. There we go. In your responses. There we go. Boop, like that. That's what we could do. So we'll start off with that. And then we're going to give it all the requirements that it needs. Yeah, we'll try that with this one. I know there's a lot of hodgepodge code in here and suboptimal, to put it politely, of what's going on. We're going to go back and fix it later. We are. Once we hit a milestone, we're going to run back through the code and actually go clean up a whole bunch of stuff. Part of this is a big learning exercise for me. Which model we're using? We're using Claude 3.7 because that's what we started the project with back in February. And I didn't want to go changing models and potentially changing the behavior of it so far. So we're just sticking to Claude 3.7 right now. Plus, I suspect the token cost isn't as high using 3.7 versus like 4.5 Sonnet. So we're using 3.7 Sonnet to let it do that. All right. So we get a language model call, we get a response, we throw that response into our working memory. We also append that into our state table messages. And then how we update the working memory, we emit that back into the working memory. I think that's fine right there. I just had a terrible thought. While this has all been very intellectually stimulating, only thing I don't like about Claude is the token limits. Are you talking about like the 5-hour working window that you get in there? Yeah, it's understandable. So, guess what I just... Guess what I just realized, and would actually have worked really well with everything we've already built without having to go add that stuff right there. Well, I like this idea, and I like the idea of the working memory. You know what we could have done is we could have just told... Actually, we don't even have to tell the exploit planner to do this. We can just do it in the code. We could append one more extra step onto here that says craft the initial access exploit. And then as it runs through the loop, it hits the last step. It tests it, it hits it. Hold on. Let me go look at something in the state table. I wonder if this is actually a valid idea, in which case I have to just go burn down all the code I made and make myself a little sad, but that's okay. Crying big fat manly tears is part of the process. All right, so we look at the exploit planner here, right? So one of the example outputs is get the web shell artifact, navigate to the panel, upload it, access it here. Yeah, one thing we could do is after it gets this data back, it actually goes through and formats those as steps for the exploit task. We could literally just go in. Why did I think of this before? We could just go into the planner and at the end inject another step that says create the initial access exploit. And then when the exploit reviser realizes that that's done and it validates that the last step is completed, take that and then just go stick it over in the host table. And so we don't need this. We don't need this. It just pops right up to the exploitation agent. This payload crafter actually might be helpful for something else. So what I'm going to do is I'm going to basically hide this from the graph. We're going to take these out of the workflow for now. So these are going to stay right here. But what we're going to do is we're going to take out these parts. So the payload crafter router, we're going to take that out. So let me do something right quick. So I need to copy this real fast and basically take each of these and just comment out this code right here. Nope, not like that. There we go. So what we've done now is from the reviser, and then we're going to modify this. This is going to go to the payload crafter. This is going to go to the exploit agent. So by commenting those out, what we've done is all those functions still exist. We have just hidden them from the workflow so they never get executed when this happens. And it looks like it patched it in, right? So let's come look at this. So now, look at that. So the edge conditionally goes up to exploit agent, just like this. And then once that's done, it should pass it back over to the validator for the validator to run the initial access exploit and make sure it works. We've already got all the information for revision and testing looping. This just makes perfect sense. So now let's go over to the exploit planner, the step planner. Let's see. Where's our exploit step planner? Right here. So when we make our steps, right, we're running this as a Lambda function here, where we do create exploit step X, where we just do a list map against all the steps in here. why didn't I think about this before? What type of data is this going to be? It's going to be a list. I didn't type this for some reason, but we'll type it now. So this is going to be a list of exploit steps right here. And I gotta remember, how did this create exploit step 1? I can't believe I didn't do this real quick. Yeah, all it does is take in the step task. Let's see. Let me make a note of that. Let's see. Takes in step task string and returns exploit step. Just like that. Boom. All right. I've been meaning to docstring everything and type everything as it comes through. So now, with this, what we do is we just go append one more onto this. So we go to exploit, let's see, steps. And what we're going to do is we're just going to append onto that list one more exploit step. And what we'll do is we'll just call create exploit step. Let's see. And what we're going to do is we're going to tell it to create initial access exploit for the target. There we go. All right, Dr. Breaky, you have a good night, man. I'll catch you later, sir. Thanks for stopping by, brother. Appreciate it. All right. Dude, this is actually, if this works, I'm going to laugh my ass off. So, what are we up to on the swear jar? 81. Okay. Almost time to go make a charitable donation. I know y'all can't see this over there, but there's a swear jar. I'm trying to cut down on cussing, believe it or not. Sometimes it still happens, though. So, when this hits increments of 50, I'm supposed to go make a $50 donation to a charity. It's been so long, I forgot to do this one. So when this actually hits, yeah, it's restricted, Gumby. Ha, sucker. But when that hits 100, I will go make the donation. I just forgot at the 50 mark. So when it hits 100, I'll do that and reset it. I knew you were going to try and spam that one. I know you guys. You're your own little special breed of trolls. All right, let's see. I think that'll actually work. And if that's the case, then where did we die? Hold on. I got to go see where it failed at the last one here. So we hit an issue here. I think we hit it with the exploit step processor. List index out of range? Why would that do it? Hold on. Oh, so the reason is because it did not come up with a proper file name for it. So it was like, hey, what? Basically, he's asking, hey, what file name did you want for this? Because that's what that function takes. So let's go clean up that prompt again real quick. Which prompt is this one using? Exploit planner prompt. Let's go to that. So in this prompt over here, what we're going to do let's add another condition for this. So we have conditions for planning steps. All steps should be constructed and performed by calling tools. Do not include any security bypasses, i.e. double file extensions or obfuscating code. Provide a condensed list of the minimal steps to accomplish the task. Let's see. Actually, I take it back. This was not in the planner. I stand corrected. This was actually in the exploit step processor prompt. So this is the wrong prompt. Let's see. So we already got this one updated here where we add in we basically inject that last step into it. And so here's our exploit step processor. Oh, I already did this. Yeah, we can take that out. Cool. Let's see. Where's our language model prompt? Here it is. The step prompt template. That's the one we want. So in this one, we need to add some conditions to this guy. Let's see. Yeah, let's add one to this. Let's see. Let's see. For any... Let's see. For file name... Well, just put a condition. Choose appropriate file names. Yeah, choose appropriate file names. Pretty much, yeah. We'll just let it do that. Hey, by the way, just choose this. Boop. We'll throw this in here, and then there's our agents. Actually, what did that look like in this guy? In our system prompt? Yeah, it looked like that. So it had this right here. So actually, I'm going to take that back out. That's fine. Perfect. Perfect. Okay. We'll say choose appropriate file names for any tool calls. There we go. Excellent. I'm not pooping, Gumby. I'm right here, dude. Frickin' troll. Alright, let's go try this now. Hold on. How much time do I have left on the... Oh, good. I caught it. Just in time. At an hour. Something went wrong. You logged me out, didn't you? I swear you logged me out. Yep, it did. Hang on. Log in. I'm a human. There we go. Add an hour. There we go. Caught it just in time. Boom. There we go. Excellent. Okay, I think this will actually work. And if it works, this is going to be silly. But if we look at the tool calls that it had for the step processor, right? It has that initial access exploit right here. Boom. Awesome. All right, so now what we can do is just go run it. Let's go try it. Where is this? Right here. Submit. All right. Now, one of the downsides is we have to let it go through the entire exploit process, but that's not a bad deal because if errors come up, we can go correct those. All right, let's go see what it's doing. Dude. All right, so it's getting our web shell artifact, which is bueno. So we're calling the special agent tool node, so it should be activating the browser now and do it. Oh, you know what I just realized? I bet I have an absolute... I can't do it right now while it's running because I don't know which browser it's using. I bet I've got a butt ton of abandoned Docker containers still running in there. Yep, I bet I do. Eventually, we'll need to have a check in here for tell it to go check the persistent tools and use the ones in there. But this one wouldn't have it anyway, because it's not until the state table gets saved up here in the workflow, but it's not until down here that that browser gets initialized. Let's see what it's doing down here. Because it's already moved on beyond the browser for one point. So we got the artifact. We browsed to navigate to it. And then we did a click, upload, snapshot, summarize. Let's see what it's summarized as. So I attempted to upload the PHP web shell, got blocked. Which is fine because that means it attempted to complete it. It realized it failed. Goes down to the reviser, Reviser renames the file. Excellent. What are we renaming it to? Let's see. Okay, so it's trying php.jpg, which is going to fail. Actually, it's going to go up there. I want to see what happens, though, when it tries this. Let's come down here. So we successfully uploaded the PHP web shell. And then it's going to try and do an HTTP GET on this, which isn't going to work. It's going to show the web shell is up there. But what do the revisers say? Because the revisers say, what's our task? Our task is upload the web shell here. All right, so HTTP GET hits it again. And then what does our revisor say? Oh, test the web shell by executing something like the ID command. Okay. That was our task. What did we do for HTTP GET? Oh, it did do it. It did command ID. Okay. But it's going to fail because it's going to return the HTTP or the PHP content. It's not going to actually return the command execution content because php.jpg doesn't work. This bums me out, though, because as I was thinking about this, we actually might need to change the structure of this exploit steps because it's going to kind of do this branching behavior as it comes through here. I bet it's failed out. Yeah, it failed out. All right, that's fine. Because it's kind of doing something like this. I'm going to have to paint this because I can't. Oh, there we go. All right, we're going to use the Primogen laser pointer here. So what's happening is we've got a list of our exploit steps, right? Right here. So we have all these steps that are happening as it's coming through. What can happen, though, is let's say this step right here fails. So if this one fails, it can actually come in and inject a new step prior to this. However, the way the steps are structured, it's not going to necessarily work. So like, let's say, for example, this step was, let's say this step over here was our rename, right? So we rename it, but then down here, we've got another step right here that's just the get, right? What is that? Our get, like that. So it gets it and it realizes it, and then, but it's actually failing at the calling part. So this is where it says, hey, we need to call this guy. That's not going to work, because if it comes in and injects a new step, it's injecting this new step just before this. So the new step it would need to do is try and redo the upload. The upload happened up here. So what I'm hoping I don't need to do is create like a branching structure here, where it's like, okay, we're going to try this. Okay, we hit a roadblock. We can come back to this part and branch off of it and then come down and try it. Okay, we hit another roadblock. We can come branch here. Oh, that would suck so bad. Because I know this sucker just failed out. Let's see what happens. So we do another HTTP GET. The revisor, what did the revisor say? Okay, so the command failed. The revision is to do this in the URL, but that's what the original one was. The task was to evaluate this with the ID. It did that, and it failed out. Interesting, though. So now it's talking about... So then it tries it in the web browser. It sends the web browser over there like, hey, let's let you go and do this. So it browser navigates to Dicecode web shell PHP JPEG command equals this. And it takes a snapshot and then it returns. I think we hit a recursion error in here maybe. Let's see what happens. Oh, it didn't do the summary yet. The very last thing it should do is the summary. Let's see. So many messages. All right, so based on the output, let's see if we can get the language model to understand this correctly. It appears the server is not executing our PHP web shell as PHP code. This could be due to several factors. Okay, so the revisor should then come back through and fail this. So what we need to do is access the web shell by requesting and check if adding the .php extension to the URL will help bypass it. So this is wrong on so many levels because it knows how it's made a compounding statement. This sucks. So it went down this wrong path. I think eventually what happens here is, wait a second, hold on. Now it's trying to get a PHP Diceco web shell. What happened? So it tries to do the HTTP GET again. That fails. And it tries to do another HTTP GET. It's doing the definition of insanity right now, where it's trying to hit the same thing over and over and over again. Oh, it tried to hit it with just the .php extension. That failed. So then, what does our revisor say? So that's weird though. The revisor then says, hey, go do this again and check if we get proper command execution, which we didn't. So it does the HTTP GET. That fails. Oh, so then we actually pass it back up to the exploitation agent. Interesting. So what does our exploit agent say? So here's what happened is it bailed out of this execution here and finally said, okay, we're done. We're going to pass it up to the exploit agent right here. Oh, actually, I just realized something. We may not have changed the routing function here. Let's go see what the actual error was from this. Here, we got to go all the way to the top. Ooh. There we go. What error did we crash out on? Index list out of range. Okay, so it came down here and it failed when it did the exploit processor. So what was it trying to process? Hold on, so it actually went all the way back up to the exploitation agent. The exploitation agent, what did it do? Since we fixed this routing, let's see. Here's our target. Oh god, there's so much in here. Oh, this is actually the one I want. Here we go. So task get remote code execution on the web shell. Here's our target. Oh, so it actually should have gone through and made a second exploit task. Excellent. Okay. I'm surprised we actually didn't hit a recursion limit on this. So here's what we told it when the exploitation agent fires. We've told it, you're an expert cybersecurity agent specializing in finding exploits for initial access to a target. Your primary job is to analyze the task and the target data to speculate on exploits that could be viable. So additional context could be provided for previously failed exploit attempts that could be modified or avoided. Suggest one exploit that could be viable to get remote code execution on the system. Suggestions should be simple, concise, and not speculate to the security countermeasures. Good example would be something like this. Excellent. Let's see. Oh, I need to add another line here. It says responses should be in this form, exploit and reason. Okay, yeah, I need to go fix that real fast. Hang on one sec, Bobby. I'm going to get to that question real fast here. I want to go change something in the exploit agent prompt real fast. I want to change that real quick before I forget about it. Maybe it's easiest just to start back with square one with the exploit agent to replan if any of the intermediate exploit steps fail and inject the context back into the prompt so it knows how to correct it, hopefully, for the next run. Maybe that's what we did already. I think that is kind of what we did, because here's what we've given it for this. We said get remote code execution from the web shell. Here's our target, right? And our target's got all the information to it. And here was our context. This was our failed exploit task, right? So if we look at the first iteration of when we called the exploit agent, right? Let's go back up here. So the exploit agent, if we look at the call to it, what we did is we have target information, but we don't have anything in the context. See that? Nothing in here. So it doesn't have any previous exploit attempt. So it looks like I inadvertently did go add error correcting to this. So if we come back down here, when we call the exploitation agent again, oh, the step revisor though, hold on. Then it routed back to the exploitation. So there's probably a routing error in here. Because see, we hit exploit agent 1, that means number 2, 3. We should have tried a couple other things in here. So something is funky with the routing. But that's okay, that's a simple thing to fix. So if we come up to right here. Now what we're giving it is, we're giving it all the information about the host, right? And then we're also giving it all the contextual information here about what it tried. So this is all the data on the previous exploit here. So like everything, what the task was, how it proceeded, how it failed. And then here's how it analyzed this. So I'll analyze the target and the previously exploited attempt to suggest a viable method for remote code execution by using the web shell. So based on the information provided, I can see that the target has a web server with upload functionality on panel. Uploads are stored in uploads directory. A previous attempt to upload a PHP web shell with .php.jpg extension was successful, but execution failed. So that's crucial that it figured that out. Direct PHP files are blocked for uploading. So let me make a suggestion for this. I like this. Upload a PHP web shell with the .phtml extension to bypass execution restrictions. Boom. So that should have worked. If we look at the planner here, and we come down to it, what's our output? Here's so now for the extension we get a PHP web shell artifact with the .phtml extension. Actually, I think that may work. Hold on, let me look at something real quick. For the Diceco web shell tool call, if we go to the processor here, you can specify the name, output file name. So we should see it get one with the .phtml extension. Diceco web shell. Really? You were that close. You were that close. Sounds like it should be good then if it can retain that and learn from its mistakes. Could just be an order of operations then with the agent calls. I think so, because it was so close right here. Because what was the task? The task was, let's generate the PHP artifact. And actually, it tells it right here. Get a PHP web shell artifact with the .phtml extension. Missed it by that much. It tried to the maximum, but only if it was a little bit smarter. Okay, so first thing it did is it got that, and then I bet the exploit step revisor failed it here. Oh. Actually, that should have worked. Let me think about this. So here's what it tried to do. This was step 0, right? So if we come look at, let's look right here. What does the state table look like? If we come break this sucker out, we're going to come down to number 5. We're going to collapse output 1 because now we have a second output task. So we have the task, remember, task and then exploit and then exploit step. So they nest under each other. So exploit task 0 failed. Right? Status failed. Boom. Exploit task 1 is now working. The first one was now rename the PHP web shell. The question here is, why did the router send it up to the exploit agent? I bet I screwed up on the router. I mean, I know I screwed up on the router because it shouldn't have rerouted this back up to the exploitation agent. All right, so let's go look at the, right here, the exploit step router. So close, man. Let's see. Where is my exploit step router? Let's go find it. I'm actually going to take all this code. Let's see. And actually, I'm not completely opposed to your idea of just BTFOing everything, Bobby, and restarting most of the stuff for the exploitation agent from scratch. Basically making this like a backup copy and then starting a new one where it's nice and clean to do. Let's see. Remove these functions. I'm going to put one more to do in here, which is this one. To do, remove this. All right, so where's my exploit step router? Here it is, right here. All right, so yep, that's where it hit me up. I think I even put a thing in here saying, hey, go fix this. Why did I not do this? What this should have done is it should have come right here, just like that. The scorched earth approach always seems elegant and sometimes necessary for reasons that are not clear. Or basically to clear out the gunk. Yeah, I completely agree. But I think we can salvage the situation. So what happened here is this was hard-coded to index 0. So it was always looking at the first exploit task instead of, I don't know why I did not properly index this. Maybe because I hadn't made this function yet. It's fine. This is fine. Everything is fine. What's cool though is it was really neat to see the error correction happen here, right? So what happened is the exploit agent issued its decree, the planner planned out the steps, the loop executed it, hit an error, went back up to the exploitation agent. Exploitation agent said, okay, I see where you went wrong. Here's how I want you to fix it. Exploit planner came down and it was kind of working, right? It was kind of going through here and doing this. I would have liked to have seen what it did. What does it estimate that we burned on tokens for this? What's the over under on the token usage for this? Wait, where's the token? Where's the token burn? Oh, there it goes. So in theory, we burned 186,000 tokens on this. Which comes out to that run costing us about 66 cents. Damn. Oh, that's funny. All right, so now that that's fixed, at least now we know that it was doing that. So to run this back one more time. So exploit agent said, hey, go do it this way. The step planner planned out the steps. Processors went through, it errored out. It went back up to the exploitation agent. He then analyzed it and said, okay, we failed. Here's how I want you to make the correction. The exploit step planner kind of went off the rails a little bit. I don't know how that step would have needed to happen. Because really what it did is it now had the very first step was to get a web shell with a .phtml extension. So what it should have done is called the DiceCo artifact tool call and said, hey, by the way, just name this .phtml. Instead, what it did is it generated it, it created it with .php, and then the reviser said, oh, we need to do a previous step like renaming it. Maybe that's something else we should do in the exploit step processor. Actually, come to think of it, we might actually need to do this over here. Let's see. So for getting the artifact, do we have any examples in here? We don't. So we do take the output file name, but we don't have any examples for it. So let's throw an example in here. So, examples. Like this. And then what we'll do is, let's give it some examples here. So we might just choose Diceco webshell.php. Another example we can throw in here is just maybe webshell.html, right? Let's throw another one here. We're kind of cheating a little bit with it because we're giving it like valid extensions that I know will cause command execution. But another one we could do is we could do Diceco PHP webshell.phtml5. No, what is it? PHP5. PHP5 is another valid one that would work. So this one would fail if it picked it, but we're letting it know that it can be, let's see, output file name and extension. We're going to change this a wee bit. There we go. So now we need to do one more thing. We got to go restart RoboPages. And then actually, we also need to do one more thing, which is we got to restart the server here. Because I need it to bootstrap all the new information from RoboPages that we just gave it. Okay, cool. So now that should load in all the correct tool definitions. And we can try running this sucker just again. Let's see, new thread. Run. Don't fail me now. Let's see. So what kind of extension did it choose? Okay, so it chose shell.php. That's totally fine. But actually, let me double check something. So did the new function definition happen? Let's see. Output file name and extension. Perfect. So if it has this and extension, then it's also going to have the examples in there. So if it gets back to that point where it's like, hey, go get an artifact named .phtml, then come back here. Hey, Fatherpreneur, I'm so sorry, man. I just saw your messages. I've been in the zone right here. I'm doing really well, man. Everything is going good. What counts as a curse word? Let's ask that question. I kind of take it on a case-by-case basis. So whichever one kind of comes up. I apologize, man. I'm actually working on a way to have a truly combined chat, so I make sure I don't miss any of the messages right now. And so I apologize, I just now saw your message. It also doesn't help that all the ones in Kick are the same color. Wish I could change that. That seems like a design fault. Okay, it's done really fast, so either it did a perfect job or which it didn't do because we see it errored out right here. Let's see what it did. So we got, let's look at the steps that it was going to create real fast. So where's our step planner? So our steps are obtain the artifact, navigate to the panel, upload it, access it from the uploads, test the web shell by executing a simple command like ID or who am I to verify command execution. Okay. So we get the Diceco PHP web shell. We navigate. We upload it. And then it looks like the upload fails, so then we do a file rename. So what did we choose for our file rename? Okay, cool. So we changed shell.php to shell.phtml. Perfect. Which means that was what the step was changed to. Actually, let me look at the revisor real quick, because the revisor should have inserted that rename step. Yeah, so we inserted that step, renamed the PHP shell file to an alternative extension to bypass upload filters. Awesome. So it renames it and then tries to go through and do the upload again. Let's looks like the upload happens. Let's look at the summary from the browser agent. Fast. All right, cool. Successfully uploaded it. Looks like it's good. And it should be uploaded to uploads.shell.phtml. Great. Let's see if the reviser passed that. Validated. Excellent. Nice. So then it then tests it. Well, what's the next step here? I want to see exactly what it did. So the next step for it to do was, just access the uploaded PHP web shell at there, which it did by doing the call. Okay. And we see that it worked. Awesome. So there is one more error correction we might need to add into this, which is for the reviser. It did this twice, and it's not such a big deal, but it's suboptimal. So there is a way to optimize this right here. So what we've got, let's go look at the recon agent, for example. So in the recon agent, let's bring the validator right here. Okay, so notice how we have calls from the recon agent to the validator. So what can happen here is if we get a task into the recon agent, actually, I tell you what, the enumeration agent's a better example, even though they look exactly the same. But trust me, it is. Let's bring these over here. Okay, so what happens is when a new task comes into the enumeration agent, which, for example, we tell it, hey, go figure out which version of Apache we're running. When that happens, the enumeration agent will actually go look at the host table and say, hey, by the way, can we answer this information from data we already have? So that might be something we need to do with the step planner or the reviser. Because what happened here is we had two steps that essentially they would do the same thing. It misinterpreted going and getting the file. It called the execution function, and it got command execution. So at that point, we could also just bail out of the we could also just bail out of the rest of the steps, right? The rest of the steps after that might be are going to be, scrap. Wow, hang on one sec, guys. Let's see, what did Bobby say? Exploit agent was like, yo, Blaise, I'm really happy for you. I'm going to let you finish, but I'm going to go back real quick and start over because I already have the answers. Yeah, exactly. Let's pull in a Kanye. We haven't pulled up Kanye. Hey, I'm going to let you finish, but... How could I do this? Let's take a look at something real quick here. Let's look at where the state table was when this tool call happened. So prior to this tool call, what did our exploit steps look like? So in our steps, we had obtain the web shell artifact, and then we had navigate to the upload form, rename the PHP web shell, upload the PHP web shell. We're basically doing its error correction loop. Then we had, hey, access the PHP web shell here. And when it did this, it did a call PHP web shell diceco. Perfect. So if this one completes, we know it worked. But then there was an additional step after this, which was, hey, go test it with ID or who am I to verify that it works. Okay? Those are good steps here. But these should have kind of collapsed into one another. Once we got this to work, I'm trying to see, like, is there a way I could tell the reviser either the reviser or the step processor to look at this step, look at everything we've done, and see if it's already been taken care of? I like that idea too. Bailing out if we achieve execution somehow. The kicker is, how do we flag that we have achieved execution? And where do we check for that in this workflow? I think the most logical place is actually in the step processor. Let me think about this. Things that make it go, Well, actually, there's one more thing we need to do on this. We'd actually have to have the exploit step processor make 2 different language model calls. One, to see if we've already achieved code execution based on information available. If we have, then what we could tell it is, okay, cool. We could just skip that. That makes sense? Let me look at this real quick. So if we look at our exploit step definition here, here's our exploit steps. We do have a skipped option. I put that in there. Otherwise, I was going to add it into this. So an exploit step can only exist in these states: new, working, validated or failed, or skipped. So what we could do is we could build in a second, basically like a precursor language model call.
Incoming transmission from Morano Gumby. What is coming to the right of the exploit agent on the flow graph?
What's to the right of the exploit agent? So what we have there is the exploit handoff. And actually, this isn't even needed. I put this in here before I truly understood some of the stuff about how LangGraph works. But this was in here because I thought I needed it. But really, after it completes the flow, it would just say, if I don't know where to route after this, kick it down here. So what we would do is, we wouldn't actually say route to the exploit handoff. We could tell it just route to end, and it would be done. So handoff is actually not needed. It doesn't really do anything. I thought I needed it to prepare certain information to send back up to Stinger, but we actually don't need it. So this is an artifact that needs to get removed. It's the same thing over in the recon agent, right? We've got a recon handoff. And in fact, if we go look at the recon agent real fast. If we go look at the handoff here. Let's see. Recon handoff is down here, just like this. And this is all over in the handoff function. Oh, actually, I take it back. The handoff function does do something. We tell it where to go. We tell it to go back to the parent graph. So I take that back. We do need the handoff function. I thought this was a state table preparator. No. So this command function here is a way to take that exploitation or take that graph and shunt it back up to Stinger. CFG, this is our AI hacking bot to go play Hack the Bot and Try Hack Me that we're working on. It is hella rough right now. I'm not going to lie to you. So what it does here is we've got a supervisor agent called Stinger, and it runs through recon and enumeration and exploitation steps. And right now we're working on the exploitation agent, and it's getting pretty good. There's a few logistical issues we're sorting out with it, but it actually can find the proper web shell exploit for our test case, and it's working. But we got to go clean it up a little bit. There's some edge cases that we're running into. So what we're trying to figure out is, how do we properly handle some of the exploit steps? Because what it will do is the exploitation agent will say, okay, I think this is how we can exploit the system. The planner plans out the steps. The processing loop here executes the steps and makes error corrections before handing it back up to the exploitation agent. And what we're running into is that we're running into an issue where it has achieved code execution, but it wants to continue down the task list. So we're trying to find a way to tell it, hey, by the way, if you've hit code execution, you can stop and jump to the very last task or the very last step in this exploit chain. I don't think you can solve it. Maybe. We're going to find out, though. I'm having a lot of fun coding it. There's always going to be, there's a ton of weird corner cases. Like, this is a dead simple exploit, and it still goes off way into, like, right field. It does, or way off into left field. It never just stays with the ball when it happens. Let's see. I think we can fix this, though. Because if we do a precursor call in the exploit step processor, get into high 99. Are you talking about like the ranking in Try Hack Me or Hack the Box? I'm not actually concerned about that. This project, Try Hack Me and Hack the Box are like not even like a fourth order effect of this. It was just a convenient target for going and building this and testing stuff with it. Really, this is meant for me to kind of come and have some fun with it. So I've been a professional penetration tester. I've been doing that for 7 years. So hacking on code, I do a lot. But writing stuff from scratch, I don't have a lot of experience with it. So that was one of the things I wanted to do here. Until a guy with a Tesla cam shoots? What? I'm so lost, man. Until a guy with a laser shoots a Tesla cam. What? I have no idea of what you speak. But anyway, writing this code base has been a lot of fun for me. I've been enjoying the crap out of it. Even the frustrating parts, because they're part of the learning process. Let's see here. He's either a bot or a troll, Bobby. Oh, autocorrect? Because it's like, I have no idea what you're saying there, config. I was like, is this autocorrect or Tourette's? Because one's going to make me feel bad. The other one's just going to make me laugh. All good, man. All good. That's a hell of an autocorrect. I know, right? Dear autocorrect, I'm never typing ducking. Oh, there's no redundancies in the sensors. Gotcha. He's talking about shining a laser to fry the optical sensor on a Tesla cam. Honestly, I hadn't thought about that, but that makes sense. That tracks. You'd overload that sensor and cook it. Let's see here. Let's go look at the exploit step processor real quick.
Caution. A virus has been detected.
Slyborg!
S1Y_B0RG virus detected in the network.
That's right, we're gonna send the Cookie Monsters slowing down. Slyborg and Raiders, welcome in, y'all. Hope y'all are having a great night. The Sly Gang. What's shaking? What is shaking bacons? Let me give Slyborg a shout out real fast. Hang on. Shout out Slyborg. There we go. Boop. Guys, by the way, if y'all like these kind of hacking streams, I haven't plugged it tonight, but InfoSec streams is really cool. You see Slyborg is still online, probably about to hop. J-Beers is on too. J-Beers is really smart. He's always doing bug bounties and stuff. So here, I'm going to drop this over in chat for everybody. Boop. Did you go make a planet emoji just to be able to run that, Slyborg? Look at this. Look at that. It's a planet emoji. I love it. That's beautiful. That is awesome. Thank you for coming online. Welcome in. I hope you're having a super stupendous, amazing Sunday. Hey, Pocket, what's going on, man? Hey, Psyched, what's up, brother? And Sasaga, thank you for coming online. Welcome in, guys. Dude, we're having some fun with the exploitation agent. So by the way, for everybody who just came in from Slyborg's Rig, my name's Blaise. I'm a professional penetration tester. I've been doing that for 7 years. And we're building a little partially functional AI hacking bot to play, like, try hack me and hack the box. It is currently testing the most dead simple exploit example I could find over on Try Hack Me called Root Me. It's a super simple PHP web shell upload exploit, and then after that, it's like a Python privesc. Super, super simple. But it's a great testing bed for building out our entire system here. So right now, we have is this weird graph. Don't pay any attention to that or that. They're not important. Okay, fine. You can come back down here. But this is our supervisor here, Stinger, and he hands off to our primary agents. So we've got it running reconnaissance, enumeration, and then now we're working on the exploitation agent. Once the exploitation agent is pretty solid, we're going to move on to the post-exploitation agent over here. So exploit's job is to create us an initial access exploit to just execute at least one command on the system. Once that's good, PostEx is going to first take that and upgrade it to a C2 connection. Once we get that C2 connection, then it's going to start working on rooting the box. Planet Boomfire. Oh man, did. So, besides, how you been doing, man? I hope you're doing great, brother. I had a really great day today. Went and took the kids ATV riding. They were ripping around the track, just tearing it up. Agent Zero actually was running his bike so hard he ran out of gas in like 2 hours. I was like, dang. All right, note to self, bring spare gas next time. Let's see. My guess is it's not very good. It's not, dude. This is, and I only work on this code on the weekends. I work on it during Saturday and Sunday streams. Unless I need a break, then we'll actually go pop into like a hack the box or something. Yeah, no, dude, it's total wrecked code right now. It's up on GitHub if anybody wants to go check it out. It's on the BlaiseBits GitHub. The repo is called HackTheBot. This is just a working repo. If it ever gets to the point where like I want to have like a proper release for it, this repo is going to get archived and we're going to move it into a new repository. But it's been a lot of fun, man. I did actually do something real quick. I need to add a little more time to the box here to make it through the end of the stream. All right, there we go. Let's see, been working on myself a lot lately and getting better about that. Oh, good, dude. Dude, yeah, I've been just keeping busy with work and stuff. I finally got that blog post about large language models and the attack surface around them put out. It's rather chunky. I threw it up in Discord. I also threw it up on Twitter for everybody to check out. Are you backending with large language models or a custom trained engine? So this one is testing purposes. We're using Anthropic's 3.7 Sonnet. And the only reason for that was because I had like $100 in Anthropic tokens. However, when we have failed runs like we just did up here, they get kind of chunky. So like we just burned probably about, let's see, what is this? 30 cents on this run. The previous one before this, I think burned 66 cents. So those Anthropic tokens are probably going to run out pretty fast here. Yeah, but it's been a really fun project, man. I do actually have a small AI server behind me. It's not super fast, but it's got 2 NVIDIA 1080 Ti's in it. It's an old hash cracking server, but that's chunky enough to be able to run things like GPT OSS 20B. So I do have that loaded up in there. Eventually, there will be ways to swap in different language models. It just hasn't been an issue, so I haven't implemented the code to do that yet.
Incoming transmission from RNO Gumby.
Thanks, Gumby. Appreciate it, man. Oh, you guys are funny. Hold on, there's ads running right now, and then I'll answer the question about, has it ever actually hacked anything? The answer is yes, actually. Right now, we're doing some care and feeding of it to make it a little bit more robust before we move on to the post-exploitation agent. Let me see here. So what did we do in this last run here? Oh, that's right. So hold on. Bobby just sent a message. So with respect to bailing out after execution, I suggest creating a definition of what it means first and foremost. Okay.
Incoming transmission from Morano Gumby here, 60 more bits for some tokens.
Thanks, man. I think at the rate it's getting so chunky. So to bootstrap this whole process, you notice there's a node up here called load pickle. What I've done, this is a dirty little hack, but what happens is as this entire system runs, it actually goes through this entire process. It goes through the recon and enumeration phases and then the exploitation phase here. And what happens is once it hits this exploitation phase and it hits this load pickle, let me see, where is it? Yeah. Is that right? Hold on. Oh yeah, because load pickle's the first thing. So what happens is it saves the state table. So we don't have to run the entire thing. It does save us a little bit of tokens when that happens. But what it does is it checks the state table and it saves a copy of it if it doesn't have any data. And if it has data, if it doesn't have data, then it loads it from the pickle file. So it allows us to just run the exploitation agent constantly. There's a better way to do that. If I was to go set up a database, like a Postgres database, I could actually have it go save those state tables and the state of the graph during execution to that database, and I could kind of time travel it. Maybe I'll take the time to do that after the exploitation agent. I don't want to detour on that just yet. Because honestly, this part right here, this special agent node, we took like a 4-month detour implementing this. It all started with we needed a web browser for the special agent, or for some of the exploitation steps, because this is a web shell exploit, right? I needed a web browser. So I spent a lot of time researching that and figuring out how to implement it into this. Finally, I decided to back it out even more and abstract it into what I call a special agent. So these are agents that you'll be able to write and you'll have access to all the code in there, and you could just drop it into the folder and it loads at runtime. So if you had a special agent you wanted to do, like, hey, maybe you had one that just specializes in a particular type of exploit or a particular type of reconnaissance, you could hot load that in there and tell it, hey, by the way, this is a recon special agent, and you could have it load that sucker in there. This was actually one of the major goals for this, because I personally have some professional development I'm working on for getting boned up more on Azure and AWS environment exploitation. So now with that, I can take that information, I can synthesize that over into a special agent as a secondary way for me to try and solidify my own understanding of this code. Lots of fun stuff. Okay, sorry. Let me catch up on chat real quick because there were a bunch of messages and I was waiting for the ads to run out. Okay, so has this hacked anything ever? Yes, it has. And in fact, it just did it a second ago here. Let me see. Where is it? Right here. So here's it actually getting command execution completely by itself, uploading the shell, cleaning it up, and executing it. So we have our basic command execution. The issue we're running into with this one, though, is it has a list of steps it needs to run through. But this was kind of in the middle. It wasn't in the expected place. So what we should be able to do is bail out of the steps and just go to the very last one, which creates the initial access exploit. That gets saved with the host target in the host table. So we say, oh, by the way, we already exploited that host, and here's how we can do it again if we need to go get command execution on it. So yeah, it has done it. It's not super consistent. Sometimes, like I said, it goes off on these weird tangents of trying to name it like .jpeg and see if it'll get PHP execution, and not realizing that, hey, that might fail. Let's see. I run a 3090 for similar purposes. I lucked out on this computer's running a 3060 with the 12 gigs of RAM, so I can run some local stuff, but I can't really do it while I'm streaming because OBS is using a good chunk of the graphics card while this is happening. 26-minute read. It was chunky. You can skip the history section. I put that in there for a very particular purpose, though, Psych. It's because I wanted to demystify what the language models are doing. People think that the language models are doing these like really wild reasoning steps, and they kind of are, but there was an evolution to get to that point. and it's very well understood kind of how we got there. And so I wanted to try and break that idea of, hey, we don't understand necessarily what they're doing. We have a pretty good picture from the ins and outs, but maybe not necessarily like each step of the way. So I tried to break all that down to demystify it and then bring it back to reality where we're like, okay, here's where you're implementing those language models, and here's where the accessories get added to the language model and how it balloons your attack surface as you do this. Oh, sorry, there was also a question about .NET. Do you write .NET or TypeScript or JavaScript or something? No, I have done some JavaScript development. I kind of hated it. I do a little bit of .NET, and mostly that's for like C# exploitation tooling for my day job, but I don't do a ton of it. Let's see. You can use a SQLite database or something else with long-term memory storage. I can do that too, yes. I could do that. So it just scrapes whatever and operates on that? Kind of. So what we've done in the beginning here is, one of the reasons why I chose TryHackMe is because we actually have steps already kind of defined in here. It had these questions, right? So we use these as kind of like our seed of what we wanted it to do. So for example, here's all the recon we want it to do. And these are just lists of things that we throw at it. And same thing down here for getting a shell. Let's see. Doctor, thank you for coming online. Welcome in, man. And so we bootstrap all of this information in the beginning. And there's a good reason for that. And that is because Stinger is actually really dumb. And by that, I mean, Stinger currently does not make any language model calls. It's just processing purely in code. The initializer actually makes a language model call, but it doesn't really do anything. And it just hands off execution to the primary agents to go do their thing. Eventually, once the post-exploitation agent gets implemented and created, then we're going to circle back up to Stinger, and we're going to start restricting the data that we give to Stinger. And we're going to let it basically come through and say, here's your IP address. We know nothing else about it except it's maybe called root me. Go and hack it. And that's what we're going to do with it. So we're going to kind of walk that back, and we give it a lot in the beginning. We're kind of spoon feeding it, and then we're going to start stripping it and giving it less and less until it has to just figure everything out on its own. SQLite might get write-locked if you access it from multiple projects. Well, this is running on a dedicated server. All of this stuff. Where is it? There you go. So all this is a dedicated dev box, so it wouldn't be such an issue with it. But yeah, getting a SQLite database write-locked could be a pain in the butt. Being able to exploit something like AWS requires extensive knowledge of the configuration and authentication meta. Dude, does it ever. It's freaking huge. All the permission sets in AWS. It's insane. A good ability to work from documents and doing dark fuzzing seems like a big step. Yeah, I completely agree. There will be certain like key steps I would give it, like certain tasks. So the way the special agents are constructed, here, I'll bring up the browser agent real quick, is you can actually have multiple agents defined in here, and then you can present each of those little agents in here. So you might have like an AWS IAM analyzer, or you might have like an AWS EC2 analyzer in here. And each of those could be like one package in here that's just AWS agent, right? And really it would be a whole bunch of them in here. But I really wanted this idea where, hey, you could go package an agent to handle a particular piece of information and do it. One of the ideas I'm toying with for way in the future is we would implement like a custom RAG pipeline into this, where your agent could actually ship certain pieces of information and be able to query that or make it available for like other agents to come query it. I'm still thinking about it. That's like way down the road, way after I go work on the Stinger agent. But yeah, dude, I thought I thought Azure was like, had a lot of complexity to it, and it does, don't get me wrong. Until I looked at AWS and I was like, good grief, it's just massive. It's huge the way it does. Yeah, the AWS ecosystem is chunky. It's chunker. GraphRag. So I looked at GraphRag, Bobby, and it sounds like one of those things that's, hey, it's a really cool idea, but I don't know if anybody's actually using GraphRag. I'd be really interested to see if like I would try to go find projects where people have implemented that with very little success. It sounds like a killer idea, don't get me wrong. I think the data prep to go from RAG to GraphRag is a huge step though. Yeah, it requires a lot more infra to support it. One of the other, actually speaking of which, so one of the other goals is after it gets a little bit more competent was to throw it against Game of Active Directory and let it work through that process. When we do that, there will probably be a need for additional special agents, like maybe ones that understand handling Kerberos tickets back and forth, or ones that understand Active Directory, things like that. So I think that will be another area where we'll start adding more special agents. I don't know when we'll ever get to Game of Active Directory, but that is one of the other way down the road future goals, is to let it be able to attack multi-system networks instead of just like a single CTF box. Yeah, dude, I think that'll be really cool. But like I said, this is a long-term project because I only work on it 6 hours a week. I'd work on it on Saturday and Sunday. Occasionally, I will go make like a small change in the middle of the week, but for the most part, we just work on this on the weekends. Can you imagine achieving DA from a Privesk? Oh, dude, that'd be so fun. It'd be awesome. Oh, that's what I was going to say. I was thinking about the different special agents. So, Bloodhound, right? For Bloodhound Community Edition, I was going to make a BHCE agent over here. So that way we'd have something that could go communicate with Bloodhound. You'd have to go through and probably configure it with some environment variables so it knows like where to go talk to it and where to talk to the Neo4j data, the Cypher database. But yeah, I thought that'd be really sick. Being able to make a determination based on some kind of machine learning principle would be really big. LLMs being reinforcement trained kind of bakes in that extra layer and makes it apply so many things, but its overhead a set custom model would not need. Oh yeah. If I was really hopeful when NVIDIA released the DGX Sparks that would be something viable for home model training. It looks like it might be, but all signs are pointing to not really. Hey, Range, what's up, man? Yeah, I was really disappointed in the DGX Sparks. There's actually some other competitors that are coming out with stuff like that, though. A little bit more like ones that are running some of the new AMD 3D accelerated processors. I forget the exact processor name, with unified memory, kind of like what the Mac Minis are doing, or like any of the new Macs where they've got that unified memory. Because to put this in comparison, yeah, you have a bunch of memory in the DGX Sparks, and the processor is decent. It's about the equivalent of a... What was it? I think maybe a 5080. Don't quote me on that. But it wasn't like a groundbreaking graphics processor that it had in there. But the killer was the memory bus between the processors and the memory was like 150. I think it was like 150 gigabits per second, which is pretty damn slow when you consider a Mac Mini, I think, is like 750. It was something like 15% the size of the bus speed of the Mac Mini. I was like, that's atrocious, man. So I had my hopes up for the DGX Sparks, but time to fly to China and pick up 4 of the 48 gig 5090s with the custom baked chips. There's actually, there was a crew in Brazil doing the same thing for a while there. I had seen them do something like they were making like the 5090 Super. Anonymous gifter. What's up, man? Thanks for the gifted sub. Appreciate it. Why is my ass green? Were you dragging it on the lawn like a dog? Let's see here. So what we were working on right here is, like I said, we ran into a new issue with the exploitation agent. And what happens is it actually achieved code execution, but then it had like all these other steps to do. So we're probably going to go bake in a pre-processing step here for the step processor that says, hey, by the way, look at the state of the exploit task to this point. Have we achieved code execution? If so, we're going to skip to the very last step. And then we're gonna just work on the very last step in here. So we are gonna make another small language model call here, which sucks because that means we need to go set up a new prompt for it. That was a pretty good name, man. Oh, thanks too, Bob. Man, it's just been a fun project, and it's completely unoptimized, and it's trash code. I even put that in the README down here. The goal is to solve hack-the-box challenges, trust none of this code, it lies. And then, of course, we have to have cake if there's lies. So, it's super, super rough. This thing is just, it's like you just picked up a boulder rough, right? There's nothing great about this. This is like, 7 grit sandpaper rough. But, we're having fun with it. We're going to keep working on it. We're going to build it up. Alright, let's go look at the exploit step processor real quick here. Let's see if we can maybe cue this in before it's the end of the stream. Let's see. Exploit step processor. Here we go. So what we want to do is maybe add a little bit of a check in here. So quick aside for everybody who is new in here, what's happening is each of these nodes is basically one function in Python that we have wired together using LangGraph. They have a single object of truth called the state table that it passes between each of these nodes. It gets the entire state table into that function when it is instantiated, or when it's called, and then it returns any changes to the state table at the end. So, for example, the exploit step planner comes through and makes a whole bunch of exploit steps, sticks those into the state table, and then all that new information is passed down to the processor. So what we need to do is come to the processor and have basically like a little pre-flight check that says, if we're working on step 0, basically don't do this. Otherwise, do a quick check of the state of the exploit task, and from all that information, say, have we achieved code execution? The cake is a lie! It is. Continue coding. There will be cake. Such a good game. No cake! No cake for you! Now we'd have the...
Incoming transmission from Mariano Gumby AMD 3D Phoenix is that latest FYI.
I think that's the one, Gumby. I'll have to look it up. Oh, wait, hold on. I threw it up in Discord. Hang on one second. Thank you for reminding me, because actually I shared it over in Discord, so I thought if anybody was looking for a home system, it might be something usable. Y'all started a hype train? Wow. From all y'all sending those transmissions. Yeah, here we go. This is just one of them. There's like lots of different ones that are coming out, but this is one that's going to have about 128 gigs of RAM in it, and it's half the price of the DGX Sparks, and it's using that AMD Ryzen AI Max processor right here. Ah, what the heck just happened there? So I'm looking forward to something like this. There's a bunch of different ones like this. This one is just one that I was looking at. One of my coworkers has done a ton of research on basically like the Spark competitors, and they're sounding pretty sick. So I might consider grabbing one of these. Honestly, right now, the old hash cracker is working, but for running local models, if you're looking for something, this is a pretty solid option. And here, if anybody wants to take a look at this, I will drop it over in the chat for everybody. If you so happen to be in the market. Hook together 4 of those, but it has to not suck for speed. I was researching the hell of it a few months ago. I don't know what kind of interface it has. Just looking at it right here, so you do have... You got, I believe that's USB 3. So unless you could extend something on the board, you'd be stuck with whatever your network latency is, which is probably just going to be 1 gigabit. So not all that fantastical, because you'd really want something like Thunderbolt. Wait, hold on. That says it has USB 4? Wait, have I been under a rock? USB 4 versus Thunderbolt. What's the difference? USB 4 and Thunderbolt 4 both use USB-C connectors and can offer 40 gigabits per second speed. Okay, that's a lot better, except if you're looking at something like that, you're dealing at that point with 40 gigabits per second is still like not all that fantastical, and especially compared to like the memory bus speed, which could be, 5, 6, 700 gigabits per second. I'm guessing so. I did not know there was a USB 4. I'm behind. I'm still stuck on USB 3. Got that USB-C, yo. Yeah, super slow. Yeah, that is the unfortunate part. Well, let's see here. Where was I? Yeah, so here's our exploit step processor. So we get the exploit task index. Let's see. So then it gets our current exploit task. We get our exploit steps. So actually from here, yeah, I can take this out. This is old code. We factored that out into functions to make it easier. So there's our current exploit step. So what we could do here is we could go check something real quick. Current step is from the exploit task current step. Okay. So we're just breaking those out into variables. What we can do is let's do a quick pre-flight check here. So we'll say if our current step. So if our current step is equal to 0, what we're going to do is we're going to skip. Actually, we'll just do this if it's greater than 0. Then what we're going to do is we're going to do language model call. Do LLM call to check for RCE. Yeah, so if it's greater than 0, what we'll do is we'll do a language model call to check if RCE has been achieved. If RCE has been achieved, then what we're going to do is we're going to go start modifying the rest of these things, and we're going to check. We're going to go change this. We're going to change the current step to. Actually, there's a list of things we'll have to do. We're going to need to go from the current step to the second to last step, change those to skipped as the status, and then let it just process the very last step, because the last step is the important one for generating the initial access exploit. Okay. Maybe we could just weld them together, but that seems like a warranty breaker. Just a wee smidgen. Just a wee bit of a warranty voiding there. But if you're not voiding warranties, are you really trying? Just stick it together with chewing gum and duct tape. That's right. I swear that's... So one of the reasons why I actually went into offensive security, I always had the idea to it, but I was working... I've been in IT for 15 years. I worked in blue team. I worked at basically like general IT, networking, server admin, customer support kind of thing at a college. And teaching too, because I was working in a college computer lab for Cisco networking. I did that for 5 years. And then I went and did blue teaming for about 3 years. And I was in a network that was just held together probably just with chewing gum. I was going to say chewing gum and baling wire, but that would be giving it way too much credit. And I was getting really burned out at that. So talked to a buddy of mine, and they just so happened to have like a new junior penetration tester role open up. I slid into that, and that was 7 years ago, and I have not looked back. I came here to code agents and chew bubblegum, and I am all out of bubblegum. That's right, you ain't cheating, you ain't trying. If you're not voiding warranties, you're not trying. Let's see, so do LLM call to check for RCE. If RCE happened, then what we want to do is set remaining steps to skip. Hey, Bobby, thank you for the gifted stuff. What's up, man? I appreciate that. Duke Nukem had a special place in my heart. Bro, Duke Nukem Which one was it? Was it? It wasn't Duke Nukem Forever. Let's see. Maybe it was Duke Nukem. Maybe it was Duke Nukem Forever. No, this was the recent floppy one, right? Yeah, 2011. That wasn't it. Duke Nukem. I think it was Stabbing Westward. Was that the name of the game? Duke Nukem Time to Kill? Yeah, that was it. Time to Kill. When did that game come out? That was my favorite Duke Nukem. 1998. Damn. I was 14. October of 1998. I was a freshman in high school. Yeah. Whew. I still remember that game. It was so good. The intro song by Stabbing Westward. Oh, it's lit. Coleman Cocoon. That's what I'm going to go with. Hey, thanks for coming online. Welcome in. I hope everybody's having an absolutely amazing Sunday. I used to build 3D maps from way back in the day with the sprites. Awesome. Oh, They Live too? Yes. And I love both of those movies for different... They Live, if you... I know a lot of y'all are in the chat were born with a 2 in your birth year. That's cool. There's an old 80s movie called They Live. Go watch it. It is so legit. It is an awesome, like, not too heavy, kind of like sci-fi movie. It's awesome. Highly recommend it. I give it like I give it a 7 out of 8. What are we working on? We're building a little AI hacking bot to go play hacking challenges, capture the flag games, stuff like Try Hack Me and Hack the Box. So what we're doing right now is in our agent, it actually got a little bit zealous and it completed basically what it does is it goes through and it creates an exploit task that says, hey, I think we can exploit the system this way. And then it builds a bunch of steps on how it thinks it needs to do that exploit. Worked out well, but in this case, we actually hit an edge case where it completed RCE before it finished all the steps. So we're putting a check for that over here in the step processor to say, hey, by the way, check if we've already achieved RCE. If we have, skip the rest of the steps and just go over to, and then just send that over, just execute the very last step, which basically formalizes the exploit. We call that our initial access exploit. And then work on that step and then call it good. Yes, sir. We're using LangGraph and LangChain to handle it. It's been pretty cool. I'm shocked it works at all, not gonna lie. Me too, man. And especially if you had seen some of the weird runs that it tried to do before we... So we are hand holding this a butt ton. For example, let me show you in the prompts real quick. I tried to do this in a way that wasn't like dead giving away the plot, but it's hard in the beginning. But we're doing a couple different types of prompts in here. So for example, let me come down to the bottom here. Let me find the one particular prompt I'm thinking about. Okay, so for example, the exploit planner prompt. So this is the prompt that this guy is using. So exploit agent says, hey, here's how you're going to do the exploit. The planner comes through and says, okay, here's how I'm going to structure the steps that need to get done. And then they execute in this kind of error correcting loop, right? We basically told it, hey, you're being really stupid. And we gave it a lot of information. This is by far the chunkiest prompt we've got in here. And it's using a couple different types of information. So we were very clear about how it should operate. We gave it conditions on what to do for the steps. And then we even gave it an example using a PHP web shell upload. I really feel like this is cheating. However, this is an example of how we're going to do this in the future. So it can use these kind of steps to kind of build those and then figure out some of the other ones. So right now, this is what you'd call a one-shot prompt. So this means we've given it one solid example of how to respond. When we move on from RootMe to some other very simple system that we want to go exploit, we're not updating this. we might go update it to one more really generic example, but not one that's going to be specific to this kind of situation. And even with this example, it still makes some like off the wall steps in the middle there. Let's see. But yeah, that's what we're doing, man. We're having a lot of fun with it. I think we're going to have to go, we are going to have to go make another prompt here for this, but we're going to kind of bootstrap this out real quick. So if RCE happened, we're going to set the remaining steps to skipped. Let's see. Except the last one. Yeah, for the initial access exploit. Let's see. People keep asking me, it's like, hey, is this going to take my job away? Not even a freaking chance, man. Even the real fancy, like, hacking AIs, like Expo, it's not taking your... If you work in offensive security, it's not taking your job. And a lot of people ask about that. Hey, is this going to kill security? It's like, no, bro. If anything, everything that's old is new again because the AI's writing black box code so the guys don't understand how it works. And then, God forbid, which does happen, people like me come in and look at the code during a penetration test if we find a really wicked exploit in there. Then you've got people that don't really understand the code base that have to go in and then try to grok it and then try to come up with a fix for it. So you could train a model for this on example and Halcyon and Days not need simple exploit directions. I was thinking about actually trying to go train a LoRa for something like that, but I have to go run that like on my local system. I'm running everything with Olama right now. So I was thinking about training a LoRa to do it too, Bob. But I said I'm keeping it kind of simple right now. And there's been a lot of things I've been trying to think about, like, hey, should we maybe add a LoRa capability to this? But if you're doing this most likely like I'm doing, where your AI system is separated or completely independent from your browser exploit, your HackBot instance, then how do you deal with like shipping the LoRa over to it? There's a lot of different ways that it could have made issues with it. That's why originally I was going to look at something like a RAG type pipeline where those browser agents could bring their own data pack and be able to use that to reference. LoRa's can hurt the bottom line IQ. Yeah. And that's that was one of the things I touched on the... I didn't touch on LoRa's on the blog post, actually. That'd be... Ooh, I should have talked about that. I need to go look at that. It's not... Well, the reason why I didn't talk about that is because a lot of times you're not exploiting the model directly unless you're doing prompt injection. You're exploiting everything that comes around the model. All the accoutrements, right? And I linked to an example of the Salesforce Agent Force exploit that happened. And it didn't really I think it was not an actual public exploit. It was some security researchers that found it. But I liked that example a lot because it showed that they didn't just go through and do a prompt injection. They did a prompt injection with a cross-origin bypass by finding an old domain that Salesforce had abandoned that was still counted in there. They registered that domain and then were able to exfil data from the agent that way. I liked that example a lot because it showed that those language models don't live in isolation, that you have all the stuff that surrounds them that actually are the real attack surface. They're just a probabilistic logic engine that's happening in there. Yeah. There's lots in the... Like I said, the reason I actually started this project to begin with was to learn how these agentic systems kind of work because my clients were implementing them and I wanted to know how to break them. And it's paid off big dividends like that already. And then it's kind of expanded from there. So I have to make sure I don't scope creep too much, but I do try to think about like, hey, what's going to come up in the future? All right, let's see. So if our current step is greater than 0, we're going to make a language model call to check for RCE. So we're going to need a couple things in here. Let's put a to-do in here. So our to-do for this is going to be, we need to make a prompt. We need to, let's see, create output object for our, detecting RCE. basically, so we can just get structured data back. It's going to say like yes or no, maybe with a reason. So we'll have like a structured output to come back from that. Let's see. What else do we need from this? That's really our big to do. So we need to code up the logic, and then we need to code this up right here. Let me throw a pass in here just so it stops yelling at me. Yeah, I think that'll work. So we'll do a language model check as long as we're not on the first step, right? If by some miracle we get the first step and we get RCE, this doesn't even matter, because if we always have to process the first step to even try to get RCE, right? So yeah, we're gonna skip this if we're at greater than 0. We'll do this in here. We'll make that initial check, and then we'll have an else statement in here, and then all this material will come through to the else statement. Let's see here. So yeah, let's actually go ahead and do that real quick, because we are going to need to move all of this stuff up into the else statement right here. I think we can leave the return statement as is. It's just everything else in here that's going to have to, all of these lines, we're going to put into this else block. Yeah, because all this we were already doing basically for the else part of this. Let's go ahead and bootstrap out the prompt real quick for this. Also, this original design for the prompts, I don't really like it. I think eventually what I'm going to do is I'm going to template this out into markdown files, and then we'll just ingest it and we'll dynamically generate them. But it's fine for now. Actually, I want to put this, let me back that out. Because what I want to do is I want to put this near this one right here. Boop. I want to put this over with it. I want to keep these kind of logically grouped together. So let's go ahead and define our get exploit step. Yeah, we'll call this our RCE check prompt. Yeah, that's what we'll call this one right here. And this is going to return us a chat prompt template. Just like that. And then what we'll have is we'll have our system template. That's just going to equal blank string for now. We'll have our user prompt template. Let's see, user template. Drop that right there. And then what we'll do is we're just going to return it like this. Boop. So what this is doing is just building out a template for the prompt. And this is just strictly a lang chain, or pretty much strictly a lang chain thing that it needs. Why is it saying this is from an outer scope? Where's the outer scope for this? I'm not going to worry about it. It's dumb. Where did I put that? Here it is. Put that right there to remember it. My ultimate goal in the coming years will be to work myself out of a job with a language model clone that does everything so I don't have to. YOLO mode. So basically 2 Bob's job, yeah. I even told my largest client that over the next 5 years that was my plan, and they were fine with it. Nice. Let's see. System prompt. Okay, so what do we want to do with this? What did we call it for up here? So for this, executing sequence of tasks to gain initial access to an exploit target. Okay. You are a world-class exploit analyzer. Boom. Always like to tell it that. And then we're going to tell it here is, let me bring this over. We can have a little bit of working room here. World last. There we go. So you're a world-class exploit analyzer. Check the context of the request to determine if the remote code execution has already been achieved. And Bob, you'll probably look at this and be like, my God, your prompts are terrible and ugly and you should feel bad. First off, I do. Second off, I'm starting with very basic prompts and then as needed adding complexity. So I'm trying to keep them simple and concise. And then if we need it, then we go add more to it. Let's see. Yeah, check the context of the request to determine if remote code execution has been achieved. Yeah, we'll probably just leave it like that. So for our system here, what we're going to do is we put in this like faux XML kind of thing here. So we do context, and then we'll do our actual context here. So this is the text placeholder for what we're going to inject over into it. And then we'll just close our faux XML right here. And for some reason, this kind of fake XML here helps the language model kind of focus on what it's doing. So that's why we're doing this. We're anchoring this to this in the instructions here. Let's see. Yeah, I think that'll work right here. We're going to need one more thing, which is our output formatter. Those who judge do not know. Those who do not know do not judge. Let's see. I've seen some really like creative prompts, and I look at like the ones I've done. I was like, man, those are trash. But at the same time, like I said, I'm keeping them simple. And as we come across cases, that's why, for example, where was it? The step planner. The reason why the step planner's prompt is so massive compared to all of the others is because we ran into issues and we realized there were constraints that we had to do to it. Same thing with the revisor. So the revisor, one of the issues we were running into is that the revisor was making compound statements and the steps are meant to be atomic, right? It was saying, do this and this. And I was like, okay, we can't do that in one step. That needs to be two different steps. So we had to tell it, hey, phrase this stuff so that you can understand that this is supposed to be two steps. Because it might do the first half, go through here, hit the revisor and say, oh, you only did half of it, so you failed. And then change up the step and then basically have to run through it again. Because the revisor has two options here. It can either modify the current step, or it can make a pre-pending step and it can insert it previously in the chain. What I'm trying to avoid doing is what we were talking about earlier, is rather than having this series of steps and only being able to insert the first and it breaking everything, I'm trying to avoid having like these branching paths of like, hey, here's where we need to go to try and finally achieve our exploitation. And I did not want to do branch tasking like that, because not only do I not fully grok it, but then I've got to code it. So I'm trying to be a lazy dev. All right, let's see here. So we want to grab this real quick. And so we're just going to send it one piece of information, which is the context of the exploit task here. Yep, that's all we're going to do. So let's come up right here. We can actually take this and move it up because we are going to need context for all of these. So we can just move that outside of this. And then what we'll do is we're going to say our, well, that's our exploit RCE prompt. RCE check prompt. There we go. So we'll say this, and this is just going to now call that function. And we'll have to import it. Wait, did you not import? There it goes. Because then what we'll do is we'll actually make the prompt. This is, forgot. This is the template. Drop this right here, take off the template, because then what we're going to do is we're now going to invoke it like this. So this is going to be equal to our prompt. We invoke just like that. And then what we do is we just pass in the information that we want to do as like a dictionary. So we do context, and then that's just going to be our context value right here. So this right here is going to come through and build our current context from this. So it looks at all of the, this is just a function we've made to try and like prepare the context of what we're going to zip up to it. So one thing you might want to consider is supplying the definition of the RCE or something like code execution, the ability for the attacker, attacker supplied code or command to run inside the target environment, client or server, producing observable effects such as outbound networks, callbacks, file processes. Actually, so here's something else I have found that works pretty well. Let me see if do I have Claude up here in here? Hey, I do. Okay. Don't need to do that. In the context of offensive cyber security, please define remote code execution. And so what we can do is we can actually use this. Okay, this is getting too much. Okay. Let's come edit this, because what we want to do is in a brief manner that could be used with an LLM to as part of a prompt when checking logs. Yeah, it just gave a ton of information back. But one thing I found is when we come through and if you want to know how to define something, you want to kind of figure out how the language model is going to be looking for it. So one thing you can do is you can go ask a language model, hey, define this term, so that then you can take that same series of text, put it into your prompt, and you can kind of anchor those two terms together. So, code execution is a vulnerability that allows an attacker to execute arbitrary code on a target system from a remote location. Concise one-liner for prompts. Let's see. Unauthorized execution of attacker-controlled code on a system, typically indicated by suspicious command execution, process spawning code ejection. I might just go with what Bobby sent. Yeah, I think Bobby's code is the better one. Let's just use Bobby's example. So that is a very good point. Let's go ahead and define that over here in this. Oop, let's bring that down here. Yeah. There we go. So code execution is the ability for, I don't want to say attacker supply, let's see, for arbitrary supplied code or commands to run inside a target environment, client or server, producing observable effects such as outbound network callbacks, file or process changes, or COM or script actions. Okay, I think that'll work. Because then if we had this in here and it hit that prompt and it saw that, hey, we supplied the ID command and we got valid output back from that Linux command, it should have triggered on it. All right, cool. Yes. Thank you for the suggestion, Bobby. You demand. You demand. All right, so we already have the context prepared. It builds the exploit task context. This one right here, by the way, what it does is it takes the, we pass in the state table and the exploit task index. So because we can have multiple exploit tasks nested under the parent task, right? So we find the exploit task index value. In this case, it's probably going to be 0, but it could be some other one in there before we try this. But what it does is it returns a nice little formatted string of all the steps outputs. So if the current step is greater than 0, we're going to prepare this, and then what we're going to do is we're going to go then make our language model calls. So we will do, I need one more thing in here. I need an output formatter. Actually, let me look at something real quick. In the planner, we just bound an exploit step to that. Got it. Okay. Grego Waffles. Lego my Grego Waffles. Thank you for coming online. Welcome in. I hope you're having a great Sunday. Or Monday, depending on which time zone you're in. I get a lot of folks from across the great Atlantic pond, and I love all of you. I know it is getting a little bit late. Usually, I would have ended the stream like about 26 minutes ago, but everything's kind of cooking real quick, so I'm running it a little bit long tonight. Usually, I stream 8 to 11 Central U.S. time on Saturdays and Sundays, and then also on Wednesdays. But Wednesdays, we're doing like hacker news. We're going over interesting news stories for the week. Let's see. I spent my evening reading about regex. Bro. F. I had 99 problems, and regex was 98 of them. Oh, good old regex. There's nothing regular about regular expressions. I hope you were having some success with your regex, though, man. What game soundtrack is this? If you do, I think I put it in here. Music. It links to it. So this is a mix of the Heartbound game OST, the Pirate Software's game, because he doesn't do any DMCA on it. So I was like, perfect. I got tired of fighting like crappy DMCA stuff because the problem is I had music that was legit on Twitch, but wasn't legit on YouTube. I had music that was legit on YouTube, but not legit on Twitch. Kick just doesn't give a damn at all. But I got so tired of fighting it, I finally went to look for ones that were completely DMCA free that I knew would work. So Heartbound, and then also Red Siege, which is another offensive security outfit. They make a bunch of lo-fi tracks, and they put out a couple albums there. So I've got all that kind of mixed in together. So it's probably about a 75% 25 mix, because the Heartbound OST is huge. The Red Siege one, not nearly as big. I have some other ones I need to go incorporate into the music mix. I just haven't done it yet. So this one, when we bound it, we just bound it with an exploit step. So let me think about this. How do I want to... Because I need something I can actually process on the output of it. Ooh, more DMCA music. Let me go check that out. Oh, it's from it's from YouTube, Bob. Nice. Ooh, I'm digging that. I am digging that music, man. Excellent. Okay. I will see about bringing those into the mix, because that's awesome. I liked it. Just like the first track that was on the main page. I dug that. By the way, I realize some people cannot see this, so let me drop that into the YouTube and Kick chat real fast. Whoop, there we go. If y'all want to check out 2Bob's music, I'm liking it though. I was digging the first track there. Oh, it's a random track each time you visit? Dang, I'm not going to know what the one I had was. I'll find it, though. Because the first one that came up, whichever one that was, I was digging it. I liked it. I guess I could just make this an output formatter. No, output formats are a little bit weird in here. No, we could do that. Yeah. Yeah, we'll just do that. We'll make it a, let's see. We have exploit step status. We'll make a new class in here. Let me bring this down. We'll do class. We'll do, we're going to call this exploit RCE check. And this will be another pydantic model in here. So we'll do base model. And we're just going to have, let's go to call this RCE, and we're just going to make it a bool. Literally just like that. And we'll make this equal to a pydantic field. And we'll give it a description. Description is... I don't want to call this. We'll say if true if code execution has been achieved. What is this thing? There we go. Has been completed. There we go. We'll just make this a real simple one, because what we'll do is, let me explain this code snippet up here, because this might look a little bit funny. So you see how we're basically taking our language model object that we're sharing around the entire code base, and we're binding a tool to it. So this might look funny, but whenever you do structured output from LangChain, this is what it's doing in the background, and it's just abstracting, taking out the tool call, which is really just a structured output format, and then it's just returning that. So the downside to that is we don't get any of the reasoning logic from the language model, and I wanted to keep that. So dug through the code, we found out if we just bind that pydantic model to this as a tool call, we get the message and we get it as like a fake tool call in there, and we can extract out all that information from it. So that's what we're doing here. This is basically our poor man's structured output. We could do structured output. However, like I said, what I wanted is the language model reasoning for it. Let me give you a concrete example. So if I come back over to here, now look at this. Let's see. Where's our step processor? Here we go. So for our step processor, we pass it all these tools, right? All these tools that it has options to call, and we get all this information. When it responds, we get all this information about what it's going to do. Hey, I'll help you access the PHP web shell. Based on the context, I see we've successfully uploaded it. Yada, yada, yada. And then we get the actual tool call structure down here. If we do a structured output in LangChain, we don't get any of this information to track it. It's basically just disappears into the void. So instead, by doing this kind of workaround, we get the actual reasoning steps from the language model and the tool output, and we can just control the flow from there. I do structured text languages from industrial firmwares in Pascal. This does not look weird. Man, I wish Foil Hats was in here, because if he was, he does a lot of PLC like work on them. I can't explain exactly everything he does, but I think he even is going through and like designing PLCs and stuff. You and he might have some really interesting conversations. All right, let's see. So down here in our exploit step processor. Yeah. So this is what I'm basically going to duplicate real quick. I'm just going to copy this, in fact. So after we build the context, we're going to put this right here. And then rather than doing an exploit step, we're going to do exploit RCE check. And then this is now going to be our RC check prompt. There we go. Oh, I need to import that. Let me take this out. Okay, so we did our LLM check for the RCE. I'm gonna put this right here. And then next thing we'll need to do, unfortunately, that is kind of where I need to wrap it up tonight. Every minute I go past the end of the stream time, it's 1% increased aggro from my wife. So, Bottle Deck, hey man, dude, you're popping in just as I'm about to like wrap up the stream. So, but I think this is gonna work. I think this will help fix that shortcut and trying to continue running through the steps when we don't need to. So, let's see. So we'll get back to this next weekend. What we're gonna do is we're gonna check in from this response to see if RCE happened. If it did, we'll go through and we'll adjust the state table accordingly. I already made the prompt, I already made this, so this can all go bye-bye. Let's bring this up. Like that, dude. I feel the wife stress. No, she's actually really sweet and she's awesome. Her codename is SOC, the Supportive Organized Caregiver. Not to be confused with the Security Operations Center, which we all know and love. Let me see if J-Beers is still online. In theory, he is. Let me see. Because if so, we can go right over to him. Because he's doing nugs. He's doing tender nugs over here. But that actually does mean he's still online. So perfect. Let me go set that up. J-Beers is super awesome. He's usually always doing bug bounties. He found a really killer exploit. I don't remember the details of it, but it was in T-Mobile. And when he told me about it, I was like, no, you didn't. He's like, yeah, I did. J-Beers. There we go. Yeah, we're going to go right over to him. All right, guys. I love all of y'all, but unfortunately, that is where I've got to wrap it up. I do have to do, adult jobby things and parenting things in the morning. But everyone, thanks for coming to hang out. Hey, do me a favor. When you get over to J-Beers' page, which, by the way, I'll drop it over in YouTube if anybody wants to go check it out. What was his? Hang on. Let me grab the link for it real quick. Here we go. So everybody over at YouTube, if you want to go check him out, when you get over there, do me a favor. Drop a bunch of Hack the Planets. Drop those on him. He's going to love it. Yeah. Two Bows, thanks for all your help, man, and your advice. Bobby, you too, with everybody. You guys are awesome. You guys have a fantastic week. Tomorrow is Monday, or if it's already your Monday, I want you to get into crushing it mode. We do not go weekly into the week. We go through and we go into crushing mode. Get after it. Get that work done. I have faith in every single one of you. Let me see. What else? Oh, I forgot. There's one super important thing. I want all y'all to remember that I love you. Peace. Had to sneak that in to go.
Incoming transmission from Marano Gumby. Love you long time. See you next time.
Love you long time. Later, y'all.